Honestly, what we just learned in this lesson might be one of the most difficult parts of understanding forms in React. So for those of you that were able to follow along, awesome, good job. For those that were struggling still, that's completely okay and completely normal. Don't be afraid to go back, rewatch this a few times, and because of that, in the next screencast, we're going to practice this a little bit more. Hopefully in this challenge, you'll get a chance to see why it's beneficial to structure things the way that we just learned how to do. Your challenge is to add an email field and associated state to our form. Pause the screencast and work on this challenge. Previously, when we were saving all of our state as strings, anytime we wanted to add new state, we needed to create new variables and new event handler functions. Now, however, we simply need to add a field to our state object here. We'll add an email property that starts as an empty string. And as long as with my input I give it the correct name, I really don't need to change anything about my handle change function. So let me add another input here. I'll just duplicate this one. For good measure, I'll change the type to email. Of course, we'll change the placeholder. I don't need to change my onChange. We'll make sure that this name exactly matches the name that we chose in state on our property here. And well, I believe that should do the trick. I'll hit save, type in a first name, we'll say it's Joe, last name Schmo, joe@schmo.com. And sure enough, our state is updating exactly as we would expect, now maintaining all three of these properties. Now, for those of you that followed my directions a few screencasts ago and actually read through the React Forms documentation, you would have come across a section that talked about controlled inputs. As of right now, our inputs are not controlled, and so in the next screencast, we're going to see one simple addition we can make to turn them into controlled inputs, and we'll talk briefly about what a controlled input is in the first place. A term you might hear floated around as you're learning about React is something called controlled components. Again, if you read through the React Forms documentation, you'll have come across the section called controlled components. If it's been a minute or you didn't have a chance to read through that, you can click this slide in order to go directly to that documentation. But when we're talking about maintaining state inside of a component, there's a common concept called the single source of truth. The idea is that the state that you're maintaining in your component should be the single source of truth. If you think back to when we were learning about changing state and we had our boxes or squares example, one solution we came up with was allowing each box to take the incoming on prop and then set its own internal state based on that incoming prop. And then the box itself could change its own internal state and therefore display either being filled in or not filled in. If it's been a minute since you've seen that lesson, of course, you can always go back and watch that to refresh on what I'm talking about here. The problem, as we learned then, is that we have two instances of that state that exist, and they don't necessarily match up. In other words, there isn't a single source of truth. The array of these objects was being held in state in the app component. However, each box was then changing that state essentially without telling the app component that it was changing, and therefore there was state that oftentimes would not match with one another. We have a similar concept happening here, where in the markup inside of our inputs, each of these inputs in effect is holding its own state. Think how in a regular HTML form, no React involved at all, when a user types into an input box, essentially that input box is maintaining its own state. Well, in this case, we have two pieces of state. One is being held by the input box just in regular HTML, and the other is updating on every keystroke held in our React code. Of course, we have set it up so that the state of our input box then perfectly gets mirrored by our state in React. However, a good practice in React is to make it so that your React state is what drives the state that's visible inside the input box. I totally understand this might seem like I'm splitting hairs here, but if it helps, all this really boils down to is simply adding a value property to each one of our inputs. So here at the bottom of each one, I'll add value equals and then a set of curly braces. And then all we need to do is add the piece of state, in other words, form data dot, and then the name of that specific input into that value. So we'll add form data dot, and then in the first one, I'm going to have first name, last name, and email. Visually, we're not going to see any difference here. Conceptually, however, when I type into the first name, Bob, the value of this input box is no longer being controlled by the input, but rather by React. Every change that I make runs my handle change function, which then updates the correct piece of state, which re-renders my form, and it sets the value of my form input to be whatever state is. So now state is in the driver's seat, telling the input box what to display, rather than the input box telling the state what to be. The main reason to learn this about controlled components is because sometimes if you don't set this up correctly, React might sometimes complain about having uncontrolled components. Fortunately, the concept itself is more difficult to understand than actually implementing it. So if you don't feel like diving deep into understanding controlled components, honestly, that's going to be completely okay at this point. Just remember that you need to set the value of your inputs to be equal to your state that represents that input value. There are a few more small things that we need to learn regarding forms. So at this point, we're going to speed through some of those so that we can get to a challenge that will help you practice all of this together. If only all form elements were as simple and designed the same way as the inputs that we've been working through, these text-based inputs, then our life would be so much easier. However, forms have more variety in the types of inputs you can have. For example, radio buttons and checkboxes, text areas, and so forth. Each one of these has some special considerations we need to keep in mind when we're using them in React. To start us off, let's look at the text area element. In regular HTML, text area is a little different than an input because it is not self-closing. It has its own separate closing tag. And in HTML, whatever you put inside the opening and closing tags is the value of that text area. You'll see I'll hit refresh and we get a text area that's a little bit larger. We can also set the size with rows and columns. The user can make this bigger or smaller if they need to. However, what the React team has done is they've chosen to make the text area much more similar to a text-based input. And so they've taken the closing tag away, they've made it a self-closing element. And just like our inputs, we will now add a value property to it, and that's going to be the value that's inside of the text area. Once you understand that they've changed the text area to be a self-closing element, essentially everything else we've learned about text-based inputs remains the same. I suppose in the text area case, we're probably not going to include a type because the text area is sort of its own type already, but everything else should essentially be the same as our inputs, which means that it's time for a challenge. Okay, your challenge is to add a text area for comments to the form. We do want to include these comments in our state as the user is typing into the text area itself, so make sure to update our state as well. Pause the screencast, work on this challenge. While we're up here with our state, I'm going to add a comments property to my state object and initialize it as an empty string. Then at the bottom of my form, I'll render a text area element. Again, it's self-closing. And just like the other ones, we will put a value in here that will be formData.comments. That way it can be a controlled component. We'll add a placeholder that just says, let's just say comments. We'll use the same onChange handler, so we'll have handle change. And in order for handle change to work, we need to make sure we assign the same name that we have in state. So comments and comments. Now I've added some styling. I did that directly to input, so my text area isn't going to be styled that way. Maybe I can get lucky and just add text area directly to my styles here. Let's hit refresh. And okay, well, my height's a little funny, but that's something I could always change later. Let me add a console log here so I can make sure that it's hooked up correctly to state. We'll just log formData.comments to make sure that just that one piece is coming in. Okay, awesome. Oh, I guess those styles aren't really going to work out because it's doing that text indent thing. That's kind of silly. Let's just put this in its own thing. Okay, that's a little better. Awesome job. The next form element we'll talk about is checkboxes. Let's take a look at the checkbox element. Now, checkboxes aren't just an HTML element on their own called checkbox, although to be completely honest, I kind of wish they were because that would just be a lot easier. But no, they are an input with a type of checkbox. Checkboxes are fundamentally different than what we have been working with so far with our text inputs because they just hold Boolean values. In other words, there's not going to be some kind of string text of my checkbox. Instead, there is a checked property that will either be true or false based on whether the user has checked the box or not. Before we jump into checked, let me clean up my input for just a second because right now I just have a bare box sitting here. While I was cleaning up this checkbox, I was reminded of something that we haven't yet talked about, and that is this HTML4 property. When we have something like a label that is supposed to be tied to another input, you have a couple options. You could nest the input directly inside of the children of the label. What that does is if the label gets clicked, it will automatically propagate that click down to the input. However, my personal preference is to keep the label as its own separate element and then point that label using HTML4 to the ID of an input so that they can be associated with one another. In plain HTML, you're probably used to using just for, but if you were to look under the hood at the underlying DOM element, it's really called HTML4. That's the JavaScript property for that element. Anyway, that's a digression. So now we have a checkbox that asks the person if they're friendly or not, and we want to maintain this in state. Well, because it's a checkbox, we're not maintaining a string. So up in state, I'm going to add another piece of state and actually start separating these onto their own lines to save some space here. And we'll call it is friendly. And just to give them a benefit of the doubt, we'll call it true as the default. As I briefly mentioned, to associate our state is friendly with our checkbox, we're not going to use something like a value property, but instead we're going to use a checked property. Now, because a checkbox is either checked or unchecked, the value that we put in here for checked needs to be a Boolean, or at least whatever you put in will be interpreted as a Boolean. So if I put something truthy in like the string hi, it's going to check the box. If I put in something falsy like an empty string, it's going to not check the box. But in the end, that doesn't really matter because this should be a Boolean value. So I'm going to say formData.isFriendly. Now, when I hit refresh, do you think that this checkbox will be checked or unchecked? It should be checked because our default value is true, right there. So when we say this box is checked, we are having React dictate to the box that it is checked, in fact, because that's what state is. Of course, now we've introduced a bit of a bug. I can't uncheck the box. Maybe that's a good thing. For this specific form, we don't want people to be unfriendly. But for the sake of argument, let's say we want this to act like a normal form. If we look closely at our handle change function, we have only been looking at event.target.value. However, with a checkbox, we are not looking at the value property anymore. We're looking at a checked property. So, of course, I could go out of my way to create a completely separate handle checkbox change function, but we can do better than that. Let's assume for now that we can reuse our same onChange function. We'll put in handle change as our onChange. And then let's go up to our handle change and we're going to make some modifications here. The first thing I want to talk about is a best practice that we should be following, and that is not to put the entire event.target.value and event.target.name down here inside of our set form data. At this point in the course, it's not that important that you understand why we're going to do this. But a much better way to handle this is to destructure event.target and pull out the values that we need. So we need name and value from event.target, and then I can switch this to name and switch this to value. And then, as I mentioned, when we're handling a checkbox, there's a few more things we need to pass in. One property that will come in is this type property on all of our inputs. We have a type text, email, and down here, our type of checkbox. So let's bring in that type so we can check whether or not the input that's making this handle change function run is a type of checkbox. And if it is, we're also going to need the checked property. And this is either going to be true or false, depending on how the user has interacted with the checkbox. Now comes a bit of a trick. When I'm setting my form data, I want everything else essentially to be the same. However, the piece of state that I want to update, if it's a checkbox, in our case, the isFriendly property, should not take on value, but rather should take on the value of checked. So I can use a ternary here that says, is the type equal to checkbox? If so, I want you to use the checked property. But if not, I want you to use the value property. Let me get rid of this console log because that's from a previous screencast. Let's refresh. We'll hit the checkbox and oh no, there's a bug. So I'd like you to look at the input that we've created, perhaps compare it to some of the past inputs that we've created, and see if you can figure out what we're missing. All of our other inputs have a name property, and that's something that I simply forgot to add in. So I'm going to add a name. This needs to match exactly what is in state. We'll say isFriendly, and that way, when I hit refresh, I should be able to now check the box. Awesome. This is probably a good time to mention that everything we're learning here with forms can be really confusing and especially hard to try to memorize. Honestly, as I've been preparing this lesson, I've had to go back to some of my old notes and some of my own recordings to remember what the syntax for this actually looks like. So just think of this as a pep talk. Now, if as I'm teaching it, you're still feeling totally lost and it's not making any sense at all, that's a cause for alarm. You should be able to generally follow along, but in this case, I'm not necessarily going to quiz you on the exact syntax for everything because, well, it's just as easy to look it up if you really need to. Okay, so let's get back on that horse, and we're going to next look at radio buttons. In React, radio buttons are kind of an interesting combination of checkboxes and text inputs. I'll talk about what I mean in just a second, but in the meantime, I've put together this field set that asks about our current employment status. To skip some of the mundane stuff, I've already added the type of radio and some IDs in order to associate the labels using HTML4 with the correct inputs. So now let's talk about how we can hook these radio buttons into our form and connect it with our state. First, we need a place in state to hold all of this information. I'll add another property to our state called employment. And where checkboxes are either true or false, radio buttons, similar to inputs, will have some kind of text value to them. In this case, I want employment to be some kind of string, either unemployed, part-time, or full-time. So on a high-level overview, what will happen is when the user clicks one of these options, we will be watching for changes in these inputs, and when a change happens, it will take the value of that specific radio button that was clicked and set our state to that value. In order to associate my inputs with the correct piece of state, and also to make it so that I can't click all of my inputs the way I can now, I need to add a name property to each one of these inputs. Like we've done before, I'll set the name equal to employment, which exactly matches the property that we are saving in state. The reason we're giving the same name to all three of these radio buttons is, first of all, in HTML, that's the way that we make it so only one of these radio buttons can be selected at any given time. But it also intuitively makes sense because we're only updating one property of employment based on which one is selected. Each one of these inputs will have its own unique value, and this value is what will actually get saved as the value in state when this specific input is selected. So for the unemployment or the unemployed one, I'll put unemployed. For part-time, we'll use part-time. And for full-time, we'll use full-time. Next, I need to make sure that I'm listening for change events. So I'll add my onChange of handle change. Believe it or not, we'll also be able to use the same handle change function, and we'll see why in just a minute. And technically speaking, this should now be hooked up correctly to state. I can test that by coming up here and console logging my state. We'll just console log the employment part of it. So we'll say console log form data.employment. If I hit refresh, we get an empty string, and then when I choose unemployed, it switches to unemployed, part-time, and full-time. There's one more small thing that we need to change, and it's essentially mirroring what we did when we were setting our value equal to the state. Radio buttons are a little different because we need to specify what value the state should take on if the radio button is selected or checked. However, that means that we can't do controlled components in the same way that we did with our inputs by setting the value equal to whatever the current value of state is. But that doesn't mean we can't control these components. It's just that radio buttons are controlled in the same way that checkboxes are controlled. Here we were able to say checked equals formData.isFriendly. However, if we try to do the exact same thing with our radio buttons, we're going to run into a little bug. We'll see that here. I'll say checked equals formData.employment. And when I click one of them, well, some weird stuff is happening. This is where radio buttons differ from checkboxes in that when we are controlling the checked property, we don't simply say checked equals formData.employment because, unlike a checkbox, this is not a Boolean value, but we can make it a Boolean value by checking if the formData.employment is equal to the value of this specific checkbox. So I'll do the exact same thing over here. And now React is in charge of controlling this input rather than the input having its own HTML state. Let me walk through that one more time. Let me hit refresh. Initially, the value of formData.employment is an empty string. When I click unemployed, it runs the onChange for handle change, which we have defined here. We're pulling the name, value type, and checked out. We're setting the form data. We're bringing in all the old form data. Now we're using name, which we had set to employment, as the key for our state that we're updating. And it looks here, says, is the type checkbox? In reality, no, this is not a checkbox, it's a radio. And so it skips the checked value and instead uses this value. This value is the value that we defined here, where we said it's either unemployed, part-time, or full-time. Then when we change state, React re-renders our form. It checks to see if the current formData.employment is equal to unemployed. In our case, since that's the one we chose, then that becomes a true statement, and therefore checked is true, and all of these other checks are false. That makes it so that only one of these can be checked at any given time. In my opinion, radio buttons are probably the most confusing element to deal with in React, so if you have understood everything we just walked through, then kudos to you, truly. This is a big accomplishment, so you really should be proud of yourself. Again, you don't need to have memorized this necessarily. You can always come back to this lesson or find something on Google to help you through the syntax of this if you need it again in the future. But if you were able to follow along with the logic that we just talked through, then that really is a good signal that you understand state, you understand event handlers, and some of these little quirks about forms in general. There's one more form element I want to talk about before we move on, and that is select boxes, and we'll do that in the next screencast. The last form element we're going to talk about in React is the select box with its options. In regular HTML, it's usually set up something like this, where you have the select box. I've added an ID just so we can associate our label with it, and it has a number of options inside with a value for each option. In regular HTML, in order to grab the value of whichever one is selected, you will look for a property called selected, although that would happen in the JavaScript. But all of this is a bit beside the point because React has decided to make it a lot more similar to some of the other input elements that we have seen so far. So just like we've done with some of the other elements, we are going to add a value property here on the select itself. And this value, similar to our text inputs, will just mirror what we have in state. Now, currently we're not saving a favorite color in state. So let's go ahead and add fav color. We'll start it off as an empty string. And then down here in our select, we will say formData.favColor. We can reuse the same onChange handler that we've been using with handle change. And in order for handle change to work correctly, we need to make sure that we mirror our name to exactly equal the property that we're saving in state. So at this point, I should be able to click my dropdown, and you won't see this dropdown in the recording, but if you click onto this app and hit the refresh icon, you can test this out for yourself. I'll click the dropdown, and I see the different colors, red, orange, yellow, green, blue, indigo, and violet. I can choose green, and that will change our dropdown to green. And actually, let's go up here and change form data employment to console log our favorite color instead. So that way, whenever I make a choice like green, Our state is updating according to the value of the option that was chosen in this drop-down box. Now we do have one little issue here. If I hit refresh, we see that I'm initializing state as an empty string for the favorite color, but currently I don't have an option that represents the empty string value. One way I can change this is by providing a new option where the value is an empty string, and then maybe I put in something like choose that makes it so that the user will see choose here on the first option. I'll hit refresh. We see choose as our option, but I can still drop this down and change it to any of these other colors, just like we would expect. And that pretty much does it for any of the form elements that we're going to be talking about in this course. There's one last small thing we need to cover about forms, which is how to submit a form. And so that's what we'll cover in the next lesson. Now that we have a way to gather all of this information from our user, we need to be able to submit the form. In HTML, you might be familiar with an input of type submit. An input type submit is, well, basically just a button. And of course, the default option there is submit. We can change the value to something different, like, I don't know, send it in or something. Okay, and that changes the text of the button. Let me put a couple breaks here just to move that down a bit. However, in HTML5, they made it so that the actual button element, if it's found inside of a form, acts like a submit button. What's nice about the button element inside of a form is that you're not doing this weird value thing because it's not really a value, it's just the text of the button. So I could just put submit here, and because this button is found inside of a form element, its type is actually automatically submit by default. In fact, if you didn't want it to act like a submit button, you'd have to actually change the type to button, which looks kind of funny, button type button. So let's just make use of that default. We'll get rid of our type completely, and therefore the default is type submit. And clicking this button, because the button is found inside of a form, will actually trigger the form's onSubmit event handler. Now, back in the day, instead of having a JavaScript onSubmit handler, you might have something like a method that tells you this is going to be a post request, and you'd have an action that probably led to some PHP file.php, and then PHP would take the data and process it, do whatever you needed to do. However, we're going to essentially bypass that entire system. We're going to set up the onSubmit event handler, and let's create a function called handleSubmit. And up here, I'll actually create that function. And what's nice about the way we have set up our form in React is now, instead of having to go through every one of our inputs and gather the values right at the last second before we submit this to maybe an API, we've been doing all that work all along as we've been updating state on every change of the inputs and elements in our form. So if we pretended that we had some kind of submit to API function, we would really just be able to probably pass our form data object into that function because it's already updated. It's been updated after every change of the form. Now, just like in vanilla JavaScript, if you have built a form and gathered the data in JavaScript, you know that clicking this submit button will actually refresh this page, and it'll put all of the form values as part of a query string in the URL. That all harkens back to the original way that forms were submitted with an action property. So the first thing we will always want to do in React when we're handling a form submit is to take that event object that will get passed to this event handler and run event.preventDefault. Preventing the default means that it won't refresh our page and essentially re-render our app with all of these default values and state. Prevent default just stops all of that from happening and makes it so that we can then run code the way that we actually want to. Just to see this working, I don't actually have a function called submit to API, so let's just console log our form data. So before we test this out, let me remove some of these console logs so we can actually see what we're working with. I'll hit refresh, type in some generic values here. Okay, and we'll hit submit, and we can see we got our state object. Everything has been automatically updating as we've been typing things into our form. And maybe just to drive the point home, let me comment out this prevent default. and I'll type in some stuff here and hit submit. And you can see my form refreshed and then my URL actually updated. I'm not sure if that comes through in the recording, but this is the URL and it took all of my values based on the name property, stuck it as query strings in the URL, and it's just not what we want to do. Okay, with all of that behind us, I do want to get your hands on the keyboard practicing some of the things we've learned with forms, so that will be what we do in our upcoming challenge. Okay, we've covered a lot of ground, so before we move on, I want to test your skills and your knowledge, make sure you were paying attention. So with this quiz, pause the screencast, click into the editor, type down your answers, and when you've answered all the questions, click play and we'll go over the quiz together. Number 1, in a vanilla JavaScript app, at what point in the form submission process do you gather all of the data from the filled out form? All of that data gathering happens right when the form is submitted. Or I should say right before the form is submitted. Usually you listen for the form submit event and then you'll go to each one of the elements in the form and gather the data. So in number 2, it asks basically how is that different in a React app? Well, in a React app, we're basically not allowing the form elements to maintain their own internal state, but instead the component that houses the entire form has some React state, and that state is updated on every change of the elements in our form. So for a text form, it's every keystroke that the user types into their keyboard. For a checkbox, it's every time the checkbox changes or the radio buttons change, and so forth. So in short, we gather all the data as the form is being filled out. And of course, all that data is held in local state. Number 3, which attribute in the form elements, for example, the value, name, onChange, etc., should match the property name being held in state for that input? Well, it's the name property. Essentially, we use that name property to help us in our onChange so that we know which property in state to update whenever a change happens. Number 4, oh, that A should not be there. What's different about saving the data from a checkbox element versus other form elements? In all the other form elements, we're using the value property to know how we should update our state, but with a checkbox, we're looking specifically for the checked property. Okay, and number 5, how do you watch for a form submit and how can you trigger a form submit? Simply enough, we can add an onSubmit handler on the form element. That's how we can watch for a form submit, and we will pass a function to the onSubmit handler that will run whenever the form is submitted. So then how do you trigger a form submit? Usually that will happen with some sort of button click. As a quick reminder, in the markup, if you have a button element that's inside of a form, it will automatically act as a submit button for that form. Alternatively, and what kind of seems like the older way to me, is to use an input type submit. But to me, there's not really a benefit to doing that. Okay, awesome job on this quiz. Hopefully you were able to answer all these questions. Next, we're going to put what we've learned about forms into practice. In this challenge, your job is to connect our existing form to some local state and update that state whenever the user interacts with the form. As we've been doing, I want you to make sure that you only create a single handle change function that can manage the state of all 4 of these inputs: the email address, password, password confirmation, and the newsletter checkbox. Then when the user clicks sign up, you'll run through some logic that makes sure that the password and password confirmation match each other. And if they do, you should log successfully signed up to the console. And if they don't, you should say passwords do not match in the console. Additionally, when the form submission happens, I want you to check if the checkbox for the newsletter was checked. And if so, log thanks for signing up to our newsletter to the console. If not, don't console log anything. There was a lot of syntax that we learned when we were going through the different pieces of the form, so don't be afraid to open up in another tab some of the previous lessons that we've gone through as a reference. So pause the screencast and work on this challenge. All right, let's do this. I'm going to start with some state. I'll create state called form data and set form data using react.useState. That will begin as an object, and I can provide this object some default values. Let's have an email property that's empty, a password property that is empty. We'll call this password confirm. And let's say maybe joined newsletter. This one will be a Boolean because that's what checkboxes deal in, is Booleans. And so we'll default it as false. Or maybe if we're good marketers, we'll default it as true. And then what we can do is add these properties as a name field in each one of our inputs. So we'll add name equals, and then we'll put exactly what those properties were from up above. While I have all of these selected, I'm going to add an onChange for every one of them that will point to a function that I'll create called handleChange. And then we'll also give a value property, and I'm going to change this on our checkbox because that should be checked, not value. This way they can be controlled elements or controlled inputs, and I will make sure that we're pointing form data dot, and then we'll paste in the values that we copied above. Let's fix our checkbox. So this should say it's checked if form data dot joined newsletter is true, or not checked if it's false. And now let's go create our handleChange function. From the event, I'm going to pull out the name property, value property, type, so that we can check if it's a checkbox that made the change, and the checked property. We'll get all of those from event.target. Target represents the element that was modified in the event. Then I can run my set form data function, and I need to access my previous form data. So we'll say prev form data. And this will be the parameter to my callback function. And I'm going to use that little trick where I can return an object by surrounding it in parentheses. That way I can make use of the implicit return without having to open the body of this function and then use the return keyword and so forth. And so I'm returning an object, and that object should have all of the properties of the previous form data. But then I want to update the property based on the name value that we pulled from the input that is making this change. That's using this computed property syntax. And the value would normally just be value if I didn't have this checkbox here, because all of my other inputs are updating a value property on the input itself. However, because I do have the checkbox, I'm going to check if the type is checkbox. And if it is, then I want to set the checked property of that checkbox. That's what's going to either be true or false based on whether the user has checked the box or not. If the type is not a checkbox, then we can just use the value property to update our state. Let's do a quick check before we get to the handle submit part of the challenge. I'm just going to console log my form data, and let's see if updates happen. Well, it's good to see that my checkbox is automatically checked, because that means that it's connected correctly to state, and our default was set to true. So if I uncheck it, we get false. That's good. Email address, password, and confirm password. Cool. Everything seems to be connected the way I would expect. So we can get rid of this console log to clean up our logs down there. At this point, all that's really left is some vanilla JavaScript logic that we need to write inside of our handle submit. And hopefully when you were doing this challenge, you noticed that I already set up our onSubmit to run the handle submit function. And because our button is inside of the form element, it acts as a submit button automatically. So clicking the sign up button will trigger the submit event on the form, and therefore will run the handle submit function. And well, I accidentally deleted the event.prevent default. I don't want to delete that. I need that. Otherwise, submitting the form will submit it as if it were submitting to an old PHP or backend, which would then take all of these values and submit them as query strings in the URL and refresh the page and everything. Essentially, I just don't want to do any of that. So event.prevent default is always going to be the first thing that you'll do at the top of your handle submit function. And yeah, like I mentioned, we just have some vanilla JavaScript logic to work through. So if the password and the confirmation match each other, we need to log successfully signed up. So I can just say if formData.password is the exact same as formData.passwordConfirm, then console log successfully signed up. And in any other instance, we will console log passwords. Oh, this says do not match. That should say do not match. Passwords do not match. And then separately, we can process the data for the newsletter. And if formData. Let's see, what was it called? Joined newsletter. If that's a true value, then we will console log. Thanks for signing up for our newsletter. Okay, let's give this a test. I'll open my console, put in an email address, password, confirmation that is matching, and we'll have the checkbox checked. I'll hit sign up, successfully signed up, and thanks for signing up for a newsletter. Let's say I change this password to something different. Passwords do not match. And well, you know what? That leads me to something that I didn't mention in the challenge, but probably would make sense to do. If the passwords do not match, I don't want to make the person think that they signed up for the newsletter. So I think I'll just put a return right here after my passwords do not match so that this if statement never gets run in case they don't match. Let's try this again. We'll hit refresh. And we will make the passwords not match. Hit sign up. And we just get passwords do not match. Okay. Then if we do make them match and we uncheck, we get successfully signed up without the thanks for signing up to our newsletter. Awesome. Obviously, we didn't touch on every aspect of forms that we've learned about, but a form like this is a lot more common for you to develop than something that has every kind of form input under the sun. Awesome work on this little mini section on forms. Believe it or not, we're really rounding the corner, almost at the finish line for this section. We just have a few more things to learn before we can really tie together the remaining aspects of our meme generator project and finally tie a bow on that and call it complete. So when you're ready, let's jump right in. Now that we've learned how to save input data from text fields into state, let's revisit our meme generator and get it to an almost complete state. We created earlier the top text and bottom text fields, but they're not hooked up to anything right now. So your task is to connect the inputs into state so that every keystroke, they update the top text property in state and the bottom text property in state. Now, I've done a little bit of CSS heavy lifting for you, and that's because I really want to focus on the state part of React right now. But in short, I've added a wrapper around our image so that the whole thing is considered the meme. I made that meme a position relative so that I could set the H2s to be position absolute. This meme text is styling it to look kind of like a classic meme text. And the top and bottom classes simply stick it at the top or at the bottom of the container element. And as you can see down here, I've hard-coded the top text and bottom text, but part 2 of your challenge is to replace that hard-coded text with the text that we are saving in state. Pause the screencast and work on this challenge. I think the first thing I'll do is add the properties that I need to my inputs so that I can be watching for changes. Let's add a name property to each one. Say name equals, and then we'll have, this one is our top text, and this one is our bottom text. Next, we'll add our value properties so that these can be controlled components, and those will be meme dot, and then top text for the top one, and bottom text for the bottom one. And then we're going to need an onChange event handler. We'll call it handle change, and then we'll create that function. I'm going to pull in the event so that I can get the name and value properties from our event. So I'll just destructure those now. And that's going to be from event.target. And then I will essentially be doing exactly what I did with getMemeImage here with setMeme. I'll type it out for the practice. We're going to set the meme, and I do need access to the previous version of the meme. I need to return an object, which if I want to do that as an implicit return, I need to wrap my object, my curly braces that represent an object, in parentheses so that it doesn't think I'm just trying to open up the body of the function. And we'll copy over all the properties of the previous meme, and we will change either the top text or the bottom text property depending on what name gets pulled in from the target. So I'll use that computed property name and set its value to value. Lastly, I will update my hard-coded text to look at our object values and state. So this will be meme.topText and meme.bottomText. Okay, let's cross our fingers. I'll hit save. One does not simply walk into Mordor. Ain't that the truth? Now, it's kind of like playing roulette here. If I click get a new meme image, it's probably not going to work out so great, but we'll see that our text is staying on top and on bottom. And switching the meme image can actually be kind of a fun exercise because your text may or may not apply to the new meme image very well. Awesome work. This is super exciting. Basically, our meme image is sort of at an MVP, a minimum viable product, to push this out to our customers. In reality, we are still importing our memes data from a JavaScript file when what we really want to do is get that from an API. There's a few more things we need to learn in order to do that successfully, and that is what we're going to start talking about in the next screencast. A very common thing you'll need to do in React is interact with an API that lives outside of your application. Usually what you're doing is either requesting information from an API or sometimes submitting information to an API. Whenever you're requesting information from an API in React, usually you want to display or use that information somehow. So getting data from an API in React consists of essentially two parts. First of all, you need to get the data. And that would be using something like fetch or another tool for getting data like Axios. The second step would be to then take that data and save it to state. Once it's saved in state, your application can interact with it, it can display it on the screen, and all of the other benefits that come with saving something in state. So let's see some preliminary syntax as to what that might look like, and then as a spoiler alert, I'm going to show you why this is broken to do it this way. To start us off, let's do a fetch request to the Star Wars API. This is just a very simple API that will get us some information about Star Wars characters and planets and movies and stuff like that. I'll go ahead and resolve the promise that I get back from fetch. It will receive a response, which will be JSON. I want to turn that into a JavaScript object that I can use. And then with that data, we'll just console log the data for now. Okay, awesome. We have this object here. I'm not going to bother digging into this object. I'm just going to stringify the entire thing. So let me put that into state. And you know what? I'm actually using data in a couple places. Let's maybe call this Star Wars data and set Star Wars data. And then instead of console logging, we will set Star Wars data with the data that we get back. And then I need to make sure to update down here as well. Let's hit refresh and see what we get. Okay, there's the data from my API. Awesome. Everything seems to be working swimmingly. However, let me illuminate something that's going on behind the scenes right now. I'm going to console log component rendered. Every time the app component renders or re-renders by React, it will run this console log. So let me open my console, hit refresh, and look at this. We've got an infinite loop of component rendering. Let me comment this out and hit refresh. Now, I want you to pause and think for a second, why was this console log running over and over and over again? Pause now and see if you can come up with an explanation for why it was doing that. The reason we were stuck in an infinite loop is because this fetch lives on sort of the top level of our component. Because of that, anytime the component renders, it's going to call fetch. And every time it calls fetch, it's going to set the Star Wars data, which is updating our state and therefore causing React to re-render this component. And then it's running fetch again, setting the state, re-rendering the component, calling fetch again, setting the state, re-rendering the component. I think you get the idea. In fact, even though we're not seeing that happening with this console log commented out, it's still being re-rendered in the background. So I'm going to comment this out so that it actually stops re-rendering. And in fact, the only thing we really need to comment out is where it says set Star Wars data. When we had a console log here, I'll uncomment this component rendered and open my console. We'll see that we're no longer in an infinite loop, and that's because we're not setting state, causing the component to re-render. So this acts as a perfect springboard into the next topic that we're going to learn about, and that is how to handle side effects in React. So that is what we will tackle next. We're now embarking on a journey that leads to oftentimes considered one of the most confusing parts about React, and that is how to manage side effects. To really understand what I mean by side effects, let's take a look for a second at what React's primary tasks are. First of all, React is in charge of working with the DOM in the browser to render some kind of user interface to the page. The React team has created a really simple interface to allow us as developers to accomplish this with JSX and elements that look just like HTML. Under the hood, of course, React is taking that JSX and turning it into elements that can be displayed on the page. Another task, which we have mostly been learning about in this section, is to manage state for us. And if you think carefully about it, it's managing that state between the render cycles. In other words, React can remember state values from one render to the next. So that's another thing that React does, and we are allowed to hook into that state using the useState hook. And then naturally, its next task is sort of a combination of these two. It needs to keep the user interface updated whenever state changes. There certainly are other tasks that React is accomplishing, but you can probably boil the main three tasks down to these three. So then what is React not able to handle on its own? The major one that we're going to be discussing is any kind of side effects, or I put outside effects here. All that really means is anything that lives outside of React's purview or reach. So some examples of this are local storage on your own browser, for example. We can, of course, use code to access local storage, but React has no real hand in interfacing with local storage. Along that line, any kind of API or database interactions that occur in our code, we can write that code to interact with APIs, but React is not in charge of that code. Or rather, React has no way to know which APIs we're going to be reaching out to. Similarly, any kind of subscriptions you might have, if you include WebSockets in your application, for example, you have a chat application that updates live. And as it turns out, even if you have two different pieces of internal state that you need to sync together, or have one of those pieces of state react to a change in another piece of state, React can manage the state of each one behind the scenes, but it's not really looking at any kind of crossover between those two states. So in the end, it boils down to basically anything that React is not in charge of can be considered a side effect or an outside effect. So using this API interaction for an example, if we look at our code from before, I commented it out so that it wouldn't keep infinitely rendering, we can see that React is essentially just doing what it's told. It's trying to put something on the screen, it's trying to manage state, and it's trying to keep state and the screen in sync. If state ever changes, it needs to re-render the component. As a side note, if this were receiving props and somehow those props were also to change, for example, if those props were a piece of state in a higher up component that then changed, this component would also re-render. So with our code living here on the top level of our component, React really doesn't have a way to stop us from setting the state here, causing the re-render, which would then set the state again, causing the re-render, and so forth in that infinite loop. So the React team gives us a really nice hook called useEffect. In the documentation, this is called the effect hook. And I like to think of it as a tool that React has given us developers to use sort of like a blank canvas that allows us to interact outside of the React ecosystem, which again mostly just consists of state, props, and the user interface that it puts on the page. And I like to think of useEffect as being a tool that allows us to synchronize React state with those outside systems like our local storage or an API. Now, before we jump in, I've included here a link to the documentation. If you click this slide, you will be sent to this page where you can learn about using the effect hook. Again, think of it kind of like reading the textbook before coming to class. Now, you don't have to scour every single word in the documentation, but I do want you to take a look at it, read through it, and then when you've got a cursory understanding of the effect hook, then we'll jump into the next screencast. As you're reading through this documentation, you'll run into a line that says, if you're familiar with React class lifecycle methods, you can think of the useEffect hook as component did mount, component did update, and component will unmount combined. So if you are familiar with class lifecycle methods, I actually want to implore you not to consider this tip. If you have no idea what I'm talking about, then that's totally fine. You can forget everything that I just said about class lifecycle methods. But if you are familiar with class lifecycle methods, the modern advice these days is not to try and think of the useEffect hook as a combination of these lifecycle methods, but rather to work on retraining your approach to understanding side effects in React. I know that might be strange for me to be contradicting the documentation, but I know that I'm backed up because this is an article by Dan Abramov, who is one of the core contributors to React, and he writes this giant blog post about understanding useEffect and essentially goes in depth into how we should not be thinking of useEffect as a way to hook into lifecycle methods, but rather as a way to deal with side effects in React. If you really want a deep dive, you can click this slide to go to this page. But if you're learning React for the first time, you do not need to go this in-depth into useEffect at this time. So once you've had a chance to skim through the React documentation on the effect hook, let's jump in and start learning how to manage side effects in React. Let's begin refactoring our code here to use the useEffect hook. Just as we can access the useState hook on top of the React object, we can do the same with useEffect. So I can create a side effect by using react.useEffect. And useEffect has one required parameter and an optional second parameter. In this screencast, we're just going to learn about that first required parameter, and in the next one, we'll talk about the optional second parameter. The required first parameter for react.useEffect is a function, a callback function. And maybe so that's perfectly clear, I'm going to write this out as a function declaration. Although in practice, you'll almost always see this as an arrow function, and that's what we'll eventually transition to as well. And this function acts as a place for us to be able to put our side effects code. In the little example we have here, this fetch request is considered a side effect, and that's because it's reaching outside of React's ecosystem, but also trying to set some state in the process. Remember, this was infinitely looping because on the top level of our component, it was running this fetch and setting the Star Wars data, which was modifying state and therefore re-rendering the app, which then just ran all the code again in this infinite loop. So let's move this fetch request inside of our useEffect, and that's it. Inside of the callback function that we provide to useEffect, we're allowed to put our code that has other side effects that interact with systems outside of React. And maybe more specifically, interact with those outside systems to keep them in sync with our local state in this component. Now, I do have a confession to make. We're actually only halfway there. If I uncomment my console log and hit save, you'll see that we're still having the same problem we were having before, where we're stuck in an infinite loop. Let me comment this line out so that it doesn't keep setting state. So what exactly is going on? I thought useEffect was going to fix this problem. Well, it turns out that the code we put inside of this callback function, if we don't provide a second parameter to our react.useEffect function, then there's almost no difference between putting our code inside of useEffect and putting it outside of useEffect on the top level of our component. There is one small difference, and that is anything that we put inside of this callback function is guaranteed to run only after the user interface has been painted to the screen. In other words, only after React has taken our user interface, our elements, and created real elements on our page. So this callback function is guaranteed to run in a specific order only after this has been placed on the DOM. But for our purposes here, there's basically no difference. We're still stuck in an infinite loop. So in the next screencast, we're going to start diving into useEffect and understanding first why we need to provide this second parameter, and then what that second parameter is and how it solves this problem. I've made a couple modifications to our app here to try and demonstrate exactly what's happening within useEffect. I came up with the simplest little counter app that just has a single button that says add and something that displays what the current count is in state. The reason I did this was just to make it so that we had a really easy way to trigger re-renders and state changes on our app here. I also replaced our useEffect callback function with just a console log that lets us know that this effect function ran. You can already see what's happening down in the console, but if I refresh the site, we'll first get the component rendered console log, and then we get the effect ran console log. As we talked about before, the function we pass to useEffect will run after every render of our component. It essentially makes it no different than moving our console log outside onto the top level of our function, just like we have here. Which means if we ever wanted to change the state within our useEffect, we get caught in that loop like we've talked about a few times already. Now with my little counter, I can trigger a manual re-render by just clicking the Add button, and we can see that when I click the Add button, it updates the state behind the scenes, so it changes from 0 to 1, and it re-renders our component now with count equaling the number 1. We get our console log, which rendered because it's a function call here on the top level of our component. It then would have skipped down here and rendered our UI so that it could display the correct count now that count is set to 1. And last of all, it ran our effect, which of course runs after every render. As we talked about, the first parameter to useEffect is this function, but there's a second parameter, which, although I mentioned is optional, is something that you will almost always include. And that is something called a dependencies array. Now, don't let the name confuse you. The concept is actually not too terribly difficult. The array that we pass as a second parameter to useEffect will contain values that, if they change from one render to the next, will cause this effect to run. In other words, it limits the number of times that this effect will run, or rather it determines when this effect will run instead of running after every single render. Now, if I leave this as an empty array, it effectively tells React, I want to run this function on the very first render of my component, but then there are no dependencies to watch and trigger this effect to run again. So it ends up being it runs once when the component first loads, and that's it, never again. We can see this in action by refreshing our app, seeing that we did get effect ran, and then adding to our count. And from here, adding to our count is no longer running this effect. And that's because we have an empty array which is not looking for any changes between one render and the next. Now, if I wanted to run this effect every time count changed, I would have to make sure that my effect knew that count was one of the dependencies that signaled to the effect to run again. So now I hit refresh, it will run once, which is why we get effect ran in the console. And now every time I hit add, I'm also running my effect again. Under the hood, this is what's happening. When I hit refresh, state starts out as 0, and the component will take count and replace it with a 0 everywhere it can find it. So here we have an array with the number 0 in the first index, or the 0 index. Then when I click add, React will update the count from 0 to 1, and it will rerun my function, or in other words, re-render my app component, where everywhere I'm using count is now 1. Remember, this used to say count. Well, the second time around, it changed from 0 to 1, so now it's running this component with an array where 1 is the first index, or the 0 index in that array. Then it's going to look at the last time it saw this dependencies array, and it's going to compare an array with the number 0 to an array with the number 1. Now, I probably shouldn't use triple equals because that's not exactly what's happening here. Let me say, okay, compared to, it's going to compare this array to this array. And if any item in this array is different, then it knows to rerun this function. Now here's the question. What if I were to hardcode an array with the number 0 in here? Let me hit refresh. We can see that our effect did run, but now what will happen when I cause a re-render to trigger? If you need to, you can pause and think through that for just a second. Well, I can click add and we'll see that my effect is not running again. Why do you think that is? Well, with a hard-coded 0 in here, every time the app re-renders and useEffect looks at my second parameter of this array, it's comparing the array with the 0 as the first item in it to an array with the 0 as the first item in it. It's going to see that those are exactly the same values, and therefore it will not run this function. And that's why it's called a dependencies array. useEffect depends on these values to know whether or not it should rerun our effect. So again, when I put count, I refresh the page, count starts at 0, I hit add, count is 1, it notices that that has changed, and therefore it reruns our effect. I feel like I've repeated myself a lot here, but I'm hoping that the concept will sink in the more times you hear it. Okay, it's high time that you get your hands on the keyboard, so let me type out a quick challenge. Okay, it's your turn to write the useEffect. The useEffect should run anytime the count value in state changes, and for now, it's just going to console log something like effect function ran. Pause now and work on this challenge. We can start our effect by using react.useEffect. As a side note, just like we could destructure useState from the import statement up here, we can also destructure useEffect if we wanted to and just say useEffect. In fact, I would suppose this might be the more common way that you'll see it. But just like with useState, I'm going to use react.useEffect just so that it's very clear where useEffect is coming from. UseEffect takes a function as its first parameter. Before we had a function declaration like this. However, I am going to use an arrow function because that is how you will most commonly see it. This is just going to console log effect function ran. Now, here's something tricky. Without the second parameter, we know that this function will run anytime the app component re-renders. And right now, the only way we're causing re-renders is by clicking the add button. Let me hit save. I can click the add button and we'll see basically the same thing that we had when we had a dependencies array. However, as I mentioned, there's almost never a reason to not include your dependencies array. There certainly are instances where it may be required, but especially on the beginning end of learning React, you almost always will need to include your dependencies inside this array. If you have no dependencies, remember that means that your effect function will only run once the very first time your component is rendered. However, our challenge specifies that it should run anytime count changes, so let's very explicitly put count in here. And now I hit save. Anytime count changes, we get effect function ran. In the next lesson, let's bring back our Star Wars data and get that displaying on the screen again, but this time without an infinite loop occurring in the background. It's quiz time again. Pause the screencast, read through the questions, type down your answers, and when you're ready, hit play and we'll go through the quiz together. What is a side effect in React and what are some examples? Put very basically, a side effect is essentially any code you want to run that React is not in charge of handling. A majority of the time you can think of that as your code that will have some kind of effect on an outside system. So some examples of that might be local storage, anytime you interact with an API, something like WebSocket subscriptions. However, another example of side effects is whenever you have two pieces of state, two states that you want to keep in sync with each other. So those are the examples maybe to answer the first part of the question. A side effect is any code that affects an outside system. The two states keeping in sync maybe doesn't fit perfectly in with that, but hopefully our examples clarify that a bit. So then what is not a side effect in React? Basically anything that React is in charge of. So some examples of that is maintaining state between one render to the next and keeping the UI basically in sync or displaying correctly with the data, whatever that data might be, whether it's state or props. There's certainly other things that React is doing, but it mostly boils down to these two or three things I think we have in the slides about what its primary tasks are. So yeah, to take our elements and render them to the DOM as well. So we'll say render DOM elements. Okay, number 3, when does React run your useEffect function and when does it not run the effect function? Well, it will always run your effect as soon as the component loads. So that's on the first render of your component. And then by default, assuming we don't pass any dependencies to our dependencies array, like we ask about in question number 4, it will run our effect on every re-render of the component. So that's assuming no dependencies array. And when does it not run the effect function? Well, it will only not run the effect function if there is a dependencies array available, in which case it will not run the effect, when the dependencies in the array stay the same between renders. And maybe I should say when the values of the dependencies in the array stay the same between renders. Okay, that leads us in perfectly to number 4. How would you explain the dependencies array? Well, syntactically, it's the second parameter to the useEffect function, and its purpose is to allow React a way to determine whether it should rerun the effect or not. It ends up being an array of values that when React is in charge of re-rendering a component, it will compare the values in the original array with the values in the new array that the effect is running when the component re-renders. And if any of those values is not the same, it will rerun our effect function. So on a high level, it's simply a way for React to know whether it should rerun the effect function. Okay, awesome job on this quiz. We're really rounding the final corner on this section. We just have a few more things to cover. So when you're ready, let's jump right in. I want to work through together getting our little app back to a state where it can pull the Star Wars data without some kind of infinite loop happening in the background. So I have a small series of quiz questions I'm going to ask. First of all, what will happen when I uncomment this code and hit save? How is my app going to act with my useEffect function set up exactly this way? Make sure to look very carefully through the code here. Don't refresh the app or anything like that. Just use what you have learned so far about useEffect and the dependencies array to figure out exactly what a useEffect that looks like this means. Well, for one, we can see that we're telling useEffect that it depends on the count variable, which means that if count ever changes, it's going to run this function again. And if we look closely in the function, we see that we're receiving the data, but we're just console logging it. We're not currently updating our state with that data. Let's open the console and see if this holds true to what we expect. I'll hit save. The very first time around, it's console logging the data that we got back from the Star Wars API. And then if I change my count, it's logging it again. Not only is it logging it again, it's actually going out to the API and getting the data a second time. So that leads me to the next question in our quiz. The second question is, how will this useEffect be different if I use set Star Wars data instead of the console log? Like before, I want you to pause and look through this code, try to analyze it, and see if you can understand how things will be different now. The main difference, of course, is that we are actually going to be updating our state when we receive that data back. Updating that state is going to trigger a re-render of our entire component. However, that re-render will not change the value of count, and therefore will not change this array from one render to the next, and therefore will not rerun our effect. So let's hit save. We'll see that our data populated. It all happened kind of quickly, but really what happened in the background is our component rendered the first time, which ran our useEffect. If I haven't said it explicitly, useEffect will always run on the first render. That triggered the fetch request to go get our Star Wars data, which eventually set the Star Wars data. Setting the Star Wars data updated state, which caused the component to re-render again. So now Star Wars data is the object that we see. It rendered the Star Wars data as a JSON object to our screen. And then the effect checked to see if the old count still matched the new count. And sure enough, it did. And therefore, it did not rerun our effect. Because it didn't rerun our effect, we did not get our Star Wars data again, which would have caused that infinite loop. If I remove my dependencies array completely, then we're back where we started, where setting the Star Wars data re-renders the component, which runs our function, which sets the Star Wars data, which re-renders our component, and so forth. Now, it is pretty contrived to have a dependencies array that is looking at the count. Because if you thought all the way through this, you would also notice that if I scroll down and I click my add button, it's going to make another call out to the API. We don't have a console log or anything like that. I bet if you were to open your developer tools, you would have seen in the network tab that it did make another request out to the Star Wars API, and it did set our data here, which would have caused a re-render. We just didn't notice anything because the data that came back is exactly the same as what we had on the screen before. So that leads me to the third quiz question. What exactly should be in our dependencies array in this case? We can see that our code is not making use of count. Usually what you put in a dependencies array will also show up somewhere in the function. But right now, we're not using count to determine how this function runs at all. So if count shouldn't be in our dependencies array, what should be there? Some of you might have thought that it should be Star Wars data. But if we think through what we've learned about the dependencies array, we'll know that if I put Star Wars data in here and set Star Wars data inside the body of that function, I'm going to get an infinite loop again. Because when I set Star Wars data, it's going to change Star Wars data and it's going to re-render the app, which will then run our effect and we'll end up in that same loop. Assuming I only want this API request to happen when the app first loads, if I leave this empty because there are no dependencies for this to run, then I can successfully set up my effect so that it will just run the API request on the very first render of our component. Now we can see if I hit save, it updates our data. And actually, you know what? Let me put a console log here. I'll say effect ran. I'll hit save again. We get our data. We get the log for effect ran. But now even updating my count is not running our effect again. I know this has probably been a lot to take in, but I'm glad you've stuck with me so far. I really hope you thought through those quiz questions as I gave them to you. If not, you always have a chance to go back and re-answer those quiz questions. And when you're ready, in the next screencast, we're going to extend this example just a little bit to try and help drill in the way that useEffect is working. We're going to start right off with a challenge. I want you to combine our count with our current URL that we're using to get our Star Wars character so that clicking the Get Next Character button will do the fetch request, but for the next character ID. Right now, it's the character of 1, which, as we can see, is Luke Skywalker. And I've updated our state to begin with 1 because I don't think that there's a character with an ID of 0. So essentially, clicking Get Next Character will increment count, but instead of having a hard-coded 1 in here, it should look at whatever the current count is to make this request. While you're at it, don't forget to consider your dependencies array. Pause the screencast and see if you can get this new feature to work. There should only be 2 small changes that we need to make. One is instead of hard coding a 1 there, we can add to the end of the string our current count. Now, I prefer to use the template strings if I can, so I'm going to change this to a template string. And then instead of using plus count, I will interpolate the count value inside. Now, if I didn't make any changes to my dependencies array, think for a second, what's going to happen when I refresh and I try to get the next character? When I refresh, my component is going to run, and it will run this effect because it will always run this effect on the first render. Count will be set to 1, and so it will make a fetch request to the Star Wars API where the endpoint is people/1. However, because I have nothing in my dependencies array, nothing is going to trigger this function again. Let me put count back in here, and I need to make sure that I will rerun this effect anytime count changes. So now I'll hit save. After the first render, it went to the API and got the character with the ID of 1. We can even see here it says the count is 1. Then I'll click Get Next Character. The count is 2. And after a little bit, we get our next character, the one with the ID of 2, which is C3PO. So when I click Get Next Character, it updates count. Updating count reruns my function, or rather re-renders my component. The effect then looks at the old array, which was an array with one item with the number of 2 in it, And then it looks at the new array, which is an array with the number of 3 in it, and notices that something has changed, which is then a trigger to run my function again with the new number of 3 as count. We have a couple more things to learn about useEffect before we can check that one off our list. But before we do that, it's time that we go back to our meme generator and we use our new knowledge to apply what we've learned about making an API request and saving that data to state. So that's what we'll do next. All right, we've made it to the very last challenge of the meme generator, and then we'll have completed the project. If you remember, up until now, we've been importing our memes data from a file that I created, and this data just came literally copy and pasted from an API request to the ImageFlip API. But since that's not usually how things work, instead we're going to make that API request ourselves, and we'll do that inside of the meme component. So your challenge is, as soon as the meme component loads for the very first time, you should make an API call to this URL. Once that data comes in, you can save the memes array part of that data, so the data will look like this object, and you can save just the memes array part of that data to our all memes state. You might notice I renamed this from all meme images to just all memes, and that's because the meme data that comes in is not just an image. They are objects that contain a URL, but I thought that all meme images might be a little bit misleading. Since you know that you'll probably need to use useEffect to accomplish this API request, you should think carefully about what the dependencies will be, if any, that if they were to change, you would want to cause to rerun this function. If there are any dependencies, make sure to include them, and if there aren't any, then make sure you understand why. As a hint, if you have used async await functions before or you feel really comfortable with them, for now, don't use them. We're going to learn in the next screencast how we can successfully use async await inside of a useEffect, but it turns out it's a little more challenging than it might seem on its face. So for now, just use .then blocks to resolve the promises that come back from making a fetch request. All right, the time is yours. Pause the screencast and work on this challenge. All right, maybe right here below our state, I will make a call to react.useEffect. The first parameter is a function. I'll use an arrow function since that's the more common way you'll see it. And let me actually think about the dependencies first. Now, I want this API request to happen as soon as the component loads. And if you remember, what we're doing is saving all of those memes in our state, and then we're accessing a random one of those memes to determine what image should get showed in here. However, there's nothing that is changing in state that will actually require me to make another API request. And so since I have no dependencies for this effect, I'm just going to leave an empty array. Then inside of our effect, we will make a fetch request to this URL. So I'll call fetch, put in that URL, resolve it with the .then. We're going to take the response and parse the JSON into JavaScript. And then we'll have some data back. And before we jump into setting state, let's just console log that data and see how we're doing. We'll hit save, and awesome. Okay, that looks very similar to what we have in our memes.data.js file. So now we should be able to use set all memes instead of console log. So we'll put in set all memes. However, if you read carefully, it says that we just want the array part of the data that we get back. So I'm not going to put the data in there. If this object represents data, then I actually have data.data. Maybe data wasn't the greatest choice because we have data.data. That's an object that has a memes property, so data.data.memes. So let's put that in here, data.data.memes. Outside of my effect, I think I will just try console logging all memes. And so what should happen is on the very first render, we have no dependencies, so this effect will not run again, but on the very first render, it will fetch our memes, obviously parse the JSON, and then set all of our memes to the data memes array. Setting our state will cause a re-render, which should then run our console log a second time. This console log will run the first time that it gets rendered, and then again after the state changes. Now, of course, if I left this here, it would also console log all memes for every character that I typed into my inputs or every time I clicked the button. But for now, let's just see what this gives us. And that was confusing to me because we are initializing it with memes data. Let me actually delete memes data and then put in an empty array here. The empty array is, I'd like to think of it as an empty box that we will then fill with our memes as soon as our component loads the first time. Let me hit refresh again. Okay, and that time we got an empty array first from our first time this console logged, and then we got the array of memes from the API. Awesome. So I can delete my console log. Actually, let's see. Now every time I type something here, we're going to be logging the all memes array to the console. So we don't want that. Let's go ahead and make sure everything else is working correctly. We'll click get a new meme image. And we actually have a bug in our code. I think I'll actually make this a challenge for you. Okay, your challenge is to try and figure out why our code is broken. As a hint, it does have to do with the difference between what we were importing before from our memes.data.js file and how we were using that versus what we're setting as our state in set all memes inside of our use effect. Pause now and see if you can fix the bug that we've introduced. As we saw before, when we were importing the memes data, we were receiving this object. So we had this object, which we called memes data.data.memes. However, in state, when we were setting state, we were initializing it with the entire object, not just the memes array. So we kind of switched things up when we were setting the array in state instead of the whole object. However, down in our get meme image, we were accessing the memes array by using allmemes.data.memes. But now all memes is an array, it's not an object with a data property. So I think I can actually just get rid of this line completely and replace memes array with all memes. And I won't need this line anymore. So now I'm accessing allmemes.length and I'm indexing into all memes at our random number to receive the random meme image. So let's try again. We'll hit save. One does not simply walk into Mordor. Get a new meme image. Very nice. Just to polish things off, I'm going to clean up this challenge. I'm going to delete our memes data file. And awesome, everything is looking great. Before we can tie off a nice little bow on this section, I want to talk about useEffect for just a little bit longer. As I mentioned, if you're familiar with async await, it may have been tempting to say, well, I want this callback function to be an async function so that I can use the await keyword here and use a little bit more tidy version of our promises here. So that would look something like this, where you say the response is wait for the fetch to come back, and then you would say data is await response.json, and then you would just set all memes to be data.data.memes. If you're familiar with async await, obviously we can see this is tidier and this would be really nice to use. However, you'll never want to make this function an async function. And to really understand why, we need to talk about one more thing that we can do with this function inside of our useEffect. So before we move on, let me undo that. And let's talk more about that in the next lesson. We'll start this one off with a pretty simple challenge just to make sure you're still awake and keeping your hands on the keyboard. In our app component, we are rendering a button and a component called window tracker. And over in window tracker right now, all it's doing is displaying the current inner width of our window. Because it's directly accessing the window.inner width as soon as the component loads, that's not updating, but we're going to get to that later. So if I hit refresh, it'll give me a new window width, but we're eventually going to make it so I can change the window width and that number will dynamically update. However, for now, let's focus on this challenge. Your challenge is to create some state called show, which we will default to true. Make it so that when the button gets clicked, it will toggle that show value back and forth, and conditionally render window tracker only if show is true. Pause now and work on this challenge. Okay, let's create some state. Const show set show equals react.use state with the default of true. I'll create a function just called toggle. That will run set show. It'll look at the previous version of show and return the opposite of that. Then we'll set that up as an on-click on this button. And last of all, we will conditionally render the window tracker component if show is true. So I'll say show and the window tracker component. Easy enough. We'll refresh, and it's toggling on and off. Awesome. Now here's something to take a look at. If I widen my window a little bit and then toggle this off and back on, you'll see that our window width changed. And that's because when this component window tracker gets toggled off, it essentially is what's called unmounted. It's completely removed from the DOM. When I click it back on, it's remounted, and therefore it will rerun this window.innerWidth, which gives me the updated version of window width. The truth is, though, we can do better than this. What we can do is add an event listener to our window that listens for the resize event, and then whenever the window is resized, we can set some local state to our window tracker so that we can display the correct window width at any given width without having to toggle it on and off or refresh our page completely. However, because it's an event on the window, I can't simply add something like an on resize event like we have with other event listeners up until now. And so I'm going to have to do a little bit of manual imperative DOM manipulation. And because I'm going to be interacting with a system outside of our window tracker component, in other words, the window itself, think for a second, what tool does React give us to interact with some kind of outside system and keep our local state in sync with it? That's right, it's useEffect. So I'm going to set up an effect. We'll say react.useEffect. And I'll put my callback function in here. And when we think about our dependencies, at first glance, it could be really tempting to say, well, I want to rerun this effect if window.innerWidth ever changes. However, something to keep in mind is that this function, our component function, gets run each time the component is rendered. Right now, when the component is rendered, window.innerWidth is equal to 474. And that's a constant value that's not going to change on its own. So let's say, for example, I refresh this, I change the window size just a little bit. There has been nothing to trigger a re-render of my window tracker component because window.innerWidth is not something that automatically re-renders a component in React. So that was a bit of an aside, but I'm going to remove that. And instead, we're going to listen for a resize event on our window. So I'm going to say window.addEventListener. We'll listen for the resize event, and then we will run the following function. For now, let's just console log resized. Okay, now I resize, and we get our console log running. Awesome. The next step is something I think you can do pretty easily by now, and so I will type that out as a challenge. Your challenge is to create some state. We'll call it window width, which you can default to the current window.innerWidth whenever the component is rendered. Then inside of our event listener, you should update the window width every time it changes. And you should change our h1 to not display the window.innerWidth that it calculated the first time the component rendered, but instead to point to our new window width state variable. Pause now and work on this challenge. Okay, we will create window width and set window width. React.useState, and we'll default it to the current window.innerWidth that it calculates when the component first renders. Then inside of our callback function, instead of console logging resized, we will set the window width to be the window.innerWidth at the time that this function runs. And last of all, we will look at the window width instead of window.innerWidth. So now when I make changes here, okay, our window width is updating dynamically. Awesome. Well, now let's take a look at a little bug that we have. I'll clean up this challenge first. Remember, our window tracker component is only mounting when its parent is allowing it to render with this show variable. When it rendered the window tracker, it immediately launched or created an event listener anytime the resize event happens. That event listener is registered with the DOM itself. So even if I toggle off my component and then try to resize the window, we see that we get this warning. And it tells us we can't update React state on an unmounted component. So in the end, what happened is our window tracker is no longer a part of the DOM, but the browser itself is still listening for the resize event and trying to set the window width of an unmounted component. This is something called a memory leak. And for now, it's good enough to know that you don't want a memory leak. Now, due to the challenges that you just completed, this screencast is getting a bit long. So in the next lesson, let's address this issue of the memory leak and see what we can do to fix it. Previously, we saw that if I were to turn off my window tracker component, or rather stop it from rendering, and then run my resize event, we get this warning that talks about a memory leak. As a reminder, it's because we set up an event listener on the window, which registered it with our browser, and even removing the window tracker component by toggling it off does not automatically remove that event listener. One thing you should always try to be aware of when you are interfacing with side effects using useEffect is any potential consequences that might happen if you don't clean up the things that you do in that side effect. This is just one example where we're adding an event listener that is not getting cleaned up when this component unmounts. But there certainly are other instances of this. Let's say, for example, you are creating a WebSocket connection with maybe a chat API, and you have a little chat app that will update your screen automatically every time there's a new chat message on the server. Well, when you create that subscription to the chat API and then try to unmount the component, it's always a good idea to then sever that WebSocket connection as a way to, so to speak, clean up the effect that you have created in your useEffect. And in fact, that's actually what we're about to learn is called. It's called the useEffect cleanup. Fortunately, it's pretty easy to do. Remember, we have a function as our first parameter to useEffect, but currently we're not actually returning anything from that function. Well, as it turns out, what we can return from useEffect can be a function, and you can think of this as a cleanup function. In fact, to make that more obvious, let me put this as a function declaration. So when React runs our useEffect function here, it will receive in return another function that it can use to then clean up any side effects that you might have created. In reality, it has no idea what the side effects are that we created, so what we put in the body of our cleanup function should be something that, well, we write to clean up our own side effects. In the case of adding an event listener, there's a sister method called removeEventListener. Now, with removeEventListener, we need to pass the exact same function that we provided when we added it. And so I actually need to move this outside of the event listener and set it up. Let's call this watch width. Then I can pass in the name of watch width when I'm adding my event listener, but this allows me to then say window.removeEventListener, the resize event, and the event listener function I want you to remove is this watch width function. Okay, let's see that this is working first. I'll put a console log that says setting up inside of my watch width event listener, and then inside of my cleanup function, I'll console log cleaning up. I'll hit save. Let's resize the window. Look at our console. Okay, it's running setting up every time the watch width function runs. Maybe setting up isn't the right way to phrase that since we're actually running this every time the resize event happens, but that's okay for now. So we get a bunch of setting ups, and now let me toggle off the window tracker. Actually, let me refresh and then do one little resize, and then I'll toggle the window tracker, and we see that we get the cleaning up function that ran. And now if I resize my browser, I don't get that memory leak warning like I had before. So let's take a step back and walk through this logically to understand exactly what's going on here, because this can be a confusing topic. Our app component is deciding when the window tracker component should be rendered. As soon as we toggle that on and it renders it to the screen, it sets the window width state. It determines what that should be based on the current window width at the instant that this component gets rendered. Remember, useEffect will only run after the DOM has been painted, or in other words, once the H1 has been rendered to the screen. So after creating the state, it will render our H1, and then it will register our use effect. This use effect has no dependencies because there's nothing inside of here that's going to make me re-register a new event listener. And so it registers this event listener on the resize event of the window. And then anytime I resize, it's reacting to the event listener that I set up. And then when I toggle off the window tracker, React recognizes that this component has reached the end of its life cycle and it's about to be removed from the DOM. And so it takes the function that it received from us when it first set up our use effect, and it just runs it. In fact, it runs it kind of blindly. It doesn't know what that function contains, but we as the developers are expected to successfully clean up after our side effects. And so we remove that event listener, and it is gone. So one last recap. Use effect takes two parameters. The first one is the effect that you want to run. The second one is any dependencies that React should watch for changes in to rerun your effect function. And that effect function is allowed to return another function that can clean up after any side effects that might be lingering in case your component dies. Now, for many effects that you set up, you might find yourself not actually needing to provide a cleanup function at all, in which case that's completely okay. This is not a required part of useEffect for it to work. As always, feel free to play around with this code. I know that this can be a confusing topic, so the more time you spend in it actually playing with the code yourself, the better off you'll be. Understanding this return function does bring us back to the topic that we were talking about a few screencasts ago on how we can't use this as an async function. And so let's go back, revisit that topic, and then we'll finally be ready to recap this entire section. I mentioned in a previous screencast that we wouldn't be able to simply put async in front of our callback function for useEffect. And now that we've learned about how we can return a function from useEffect to act as a cleanup function, we will probably see why we're not able to put async in front of this callback function. If you're familiar with async functions, you know that by putting async in front of your function definition, it alters the way that function, functions in JavaScript. Whatever I return from an async function does not become a bare value return that we can receive in a variable when we're calling this function, but instead an async function will automatically and always return a promise. As I'm writing my async function, whatever I say should be returned is actually what will be resolved as the successful promise completion of my async function. However, since React is expecting the return value from my async function to be another function that it can use to clean up any side effects that I create in the process of running my effect, if what it receives instead is a promise, it's not going to be able to run our cleanup the way that we want it to. Fortunately for us, there's a really easy workaround to this, and that is to define a separate function inside of useEffect. And remember, if you're okay using .then syntax with promises, then you don't have to do any of this at all. But let's say you really are anxious to use an async function. Well, I can just call a new function. We'll call it an async function. And maybe let's say get memes. And now because it's an async function, I can move this content in here and say something like const response equals await the fetch request. Const data equals await res.json. And then with that data, I can set my memes. Now, this is just a function definition, so the very last thing I need to do before I'm done is to call my own function here inside of this callback function. This is a lot of functions to be dealing with for sure. We've got a callback function which has a function definition, a function call, and then a returned function. But again, if this is too much, then you can just go back to using .then syntax with your promises, and that's completely okay as well. In our case, with our effect, we probably don't need a cleanup function here because we're just making this one call one time. It's happening as soon as this component loads. There isn't really a built-in way for us to unmount the meme component or anything like that. And so we can just delete our useEffect cleanup function that we were returning from our callback function. I tried to take everything that we just talked about and boil it down to a written summary. So if you're interested, you can read through the summary that we just put here. And now we'll take the opportunity to take a look back at all the new things that we learned about React in this section. And we've covered a lot of ground. So when you're ready, let's take a look at all the cool new things that you are now able to do as a React developer. Holy cow, I can't believe we are finally here at the end of section 3. We have covered an insane amount of topics, and you have built your first interactive React app. I mean, even try to think back to section 2 and what we knew then versus what we know now. It's crazy. Before we wrap up this section, let's do a quick recap of everything that we've learned. One of the key components of an interactive web app is the ability to listen for events. So we learned how to add event listeners in our React app. And that was a crucial springboard for us to learn state. Then, even though we had seen a sneak peek of conditional rendering beforehand, we officially learned conditional rendering and saw a few different ways that we can implement it in our code. Then we kind of waded through one of the heavier topics of forms in React. For better or worse, you'll end up using forms pretty regularly in React. And on a side note, I hope you mostly just have to do input boxes instead of worrying about all those other kinds of types. But it's important that we learn them so that we can apply them when we need. And then we dove deep into understanding side effects and how we can handle side effects in our React code. These topics, combined with everything that we learned in the previous 2 sections, make up a really robust introduction to the React library. And of course, there's a ton more that you can still learn about React, but these foundational pieces give you the tools that you need to build your own basic web apps. Especially considering the depth of the topics that we learned in this section, you should definitely go over to the Today I Did channel in the Scrimba community Discord server and post a celebratory message saying that you finally finished section 3 of the Introduction to React course. In fact, if you click this screenshot, it'll take you right there. And the end of this section essentially marks the completion of the topics that we'll be learning in this course. However, if you know me at all, you know that I'm not going to let you go before I get you to practice this a lot of times. So the next section is completely dedicated to practicing everything that we've learned. And along the way, there's a couple new things that I'll introduce here and there. I'm really excited to jump into the next practice section, and I think you should be too. We're going to be working on some really cool projects. Before that, though, you should bask in the glory of having completed this section. So once you're all done basking, I will see you in the next section. If you're jumping into this section because you have completed all of the other sections, all the exercises or challenges, and all the projects that I have thrown your way, then congratulations. You have done a lot of work to really learn and hopefully deeply understand React. Naturally, there's a million more things you could learn about React. It's a framework you can dive really deep into and get very complex with. But at this point, you really have all of the fundamental tools you need to build highly interactive web applications on your own. So at this point, this section is dedicated completely to, you guessed it, practice. I know I've said it a million times before. I hope you're not terribly sick of me saying it, but you will not get good at anything unless you practice it over and over. We know this intuitively when it comes to something like learning a new instrument or learning a new language, and it's absolutely no different when it comes to web development. So for the remainder of this section, we will be working on 3 projects, and I want to take a second and give you a preview into what those projects are. Now, this will be a little bit different than what we've done in the past. So far, we've mostly been creating something completely from scratch. However, the first 2 projects I'm going to have you work on, you'll actually be jumping into an existing code base. And we're going to ramp up to this a little bit. The first task you'll have is to revisit our React Facts site from the very first section in this course, but now to apply the knowledge you have about state in React to implement a light mode and dark mode toggle, which will allow the user to toggle between those 2 color schemes. This one will end up being more of a warm-up project because it will only be 1 screencast long. Then you're going to jump into a new project, which is sort of a markdown version of an Apple Notes clone. Some of the basic code for this will already be written for you, but some of it will be broken, and along the way, you'll also be learning something new as you implement a new feature that interfaces with local storage so you can save these notes in a little bit more permanent way. Then for the third project, we'll go back to our roots. We'll be creating it completely from scratch, and that is this dice game called Tensies. Every single step along the way with these projects is going to be a challenge for you to complete, so you will get your hands on the keyboard and you'll get lots of awesome practice to help you really solidify the things that we've been learning about React. So what are we waiting for? Let's jump right in. We're going to start off with a sort of warm-up challenge here. Usually when you join a team as a web developer, you probably aren't going to be creating your projects completely from scratch, but instead will sort of be tossed into a new code base that you then have to spend some time becoming familiar with before you can do any kind of work on it. Now, the code base here, fortunately, is something that you have worked on in the past, and that's the React Facts site that we worked on in the first section. But I'd like you to imagine that when you finished the first version of this code, you handed it off to a team, and in the meantime, they've been working on implementing this light mode and dark mode toggle, but are needing some help for you to add the functionality to it. So a major part of this challenge is to spend a really good amount of time looking through the existing code because it has changed since you last looked at it, and make sure that you spend some time understanding how everything is working. In my little advice section here, you see it says to first start with index.js, work your way to app.js, go to main.js and navbar.js, and then to follow the CSS class names in the style.css so that you can understand how things are working. While you're at it, make sure that you're looking closely at the conditional class names in the JSX to help you decide what props need to be passed down to the components that need them. You should also think carefully about which components will need state. This is going to help you decide where you're going to write the code that initializes the state and how to then pass it down to the components that need to access it. In the slide down here, I included a couple screenshots that have both the light mode and the dark mode. You can click on either one of these to go to the Figma file that has the specific colors and other design aspects. However, in reality, the design has already been implemented. You shouldn't need to do too much in changing the design because it all is existing in the CSS. On this next slide, I also have a little animated GIF that shows you exactly what should be happening. Of course, you click the light and dark mode up top, and that will change every aspect of the site to its light mode or dark mode color scheme. Again, jumping into an existing code base like this is going to be a really common task as a developer. So when you're working on part one of my advice here, spend a real significant amount of time doing this. I imagine it will realistically take you at the very least about 5 minutes, but even upwards of 20 or 30 minutes before you maybe get a good grasp on the code that we have here. Okay, the time is yours. Pause the screencast and work on adding this light and dark mode feature. Let's start off by looking in index.js. I think we're going to find it's not that impressive here. We're really just importing app and rendering it. So let's follow that down and go to app.js. Looks like it is rendering a div with a container class name that is containing the navbar and the main elements, which we're importing up above. So let's go to navbar. Okay, this one's a little more significant. Like I mentioned, looking at the conditional class names is going to give us some good hints as to what we need to do. Here we can see that navbar is expecting props, and specifically one of the props called dark mode. I'm assuming this is a Boolean because of the way it's positioned in this ternary here. It says if props.darkMode is true, then apply the class name of dark, otherwise don't apply a class name at all. And if we look really closely, we also are expecting a prop called toggle dark mode, which makes sense because our toggle here exists inside of the navbar. So clicking this toggle should change the dark mode from true to false or false to true. The other thing app.js was rendering is this main, so let's go look at the main. It looks like main is also expecting props, again, props.darkMode, so it's going to do essentially the same thing. And I think that's it. This one is not expecting to toggle the dark mode anywhere, so we should be set up now to create the state we need to make this light and dark mode work. Now, because both the main and the navbar are expecting an incoming prop called dark mode, that means that the parent of those, this app component that contains or renders the navbar and the main, should probably be where the state is being held. So let's go ahead and create our dark mode and set dark mode, which is react.useState. Maybe since the code right now is showing that it is not in dark mode, let's set this to true so that when everything is hooked up correctly, we'll see the page update. I'll pass the dark mode prop to both of my components since we saw that they both are expecting it to come in. And then the navbar specifically is expecting something called, I think it was, well, let's just go look at it. Navbar toggle dark mode. So I'll copy that. That's the name of my incoming prop. And now I need to provide a function which will change the dark mode. I could do that inline, or my preference is to create a separate function. So we'll say toggle dark mode. And that's simply going to call set dark mode looking at the previous mode. And it'll just return the opposite since it's a Boolean. And now let's pass our actual toggle dark mode function down to the navbar. I'll create some space here. Let's hit save, and when we do that, it should switch to dark mode. Awesome. Okay, and then we can click our toggle. Great, this is working just like we'd expect. Obviously, what we have worked on here might be a bit contrived because in our case, somebody already implemented some of the major features that make this work. But that's what makes this a warm-up. We're really gearing up to work on something that's a little more in-depth. And the main takeaway I want for you in this challenge is not so much implementing the actual feature in this case, but instead taking the time required to look through the code and to understand the code. Of course, if you're working on this with a team, you'll probably have access to the developers that had written this code, and that's when you could ask them questions. Why did you write something the way that you wrote it? And that way you can get some good insight from them on how it's written and how you should proceed when you're adding new features. Okay, I feel like we're nice and warmed up, so now we're ready to jump into another existing code base, which is one of our major capstone projects for this section. As a developer, it can be really fun to start new projects from scratch, especially when that project is one of your own ideas. However, a much more common task as a developer is to be thrown into a code base that you're unfamiliar with and asked either to fix bugs or add new features. Naturally, before you're able to be productive on any code that's new to you, you need to be able to read through the code that exists to get a sort of lay of the land and make sense of what you're seeing. Only then can you start to feel confident enough in the code base that you'll be able to add new features or fix bugs without actually causing new bugs in the code or breaking an existing feature. Now, in reality, this is where something like automated testing comes in really handy. But unfortunately, you won't always have the luxury of working on a code base that has robust testing already set up for you. And so I'd like to introduce you to the Markdown Notes app. I guess I didn't get very creative with the title. This app already has some bones set up for you. You can see that there's a list of notes that will be on the left. You can create new notes like I just did with this plus button. And on the right, there's a Markdown editor where you can toggle between preview and write. Now, this editor is not something that I wrote. This is built by another team that made a package called React-MDE Markdown Editor. And we've simply implemented that package into our code here. So on each one of these notes, I can type new things into the note. I can switch back and forth between preview and write mode. Everything here is Markdown, so when I bold something, it will surround it with the double asterisks. But when I go into preview mode, it will render that as HTML, and so we see a bolded paragraph. If you haven't spent much time doing Markdown, you can play with the editor here and get a general sense of how Markdown works, toggle back and forth between write and preview. But as it stands, this Notes app has some very limited features. First of all, we see that it's just calling our notes Note 1, Note 2, Note 3, Note 4. We also have no way to delete any notes. And probably worst of all, if I refresh this app, all my notes disappear. This is the screen I set up if we have no notes, and we can click the button to create one. So before we even dive in to look at what features we plan on adding to this project, I have your very first challenge, which is to understand the codebase. I'll type it out to be more specific. Your first challenge is to spend a good 10 or 20 or maybe even more minutes reading through the code and trying to understand how it's currently working. Now, I say 10 to 20 minutes as a guideline, but you really should spend as much time as you need to feel pretty confident that you understand this existing code. Although in reality, you don't need to fully understand everything you see here just to move on. I will walk you through a high-level overview of the app, but I really urge you to actually pause, spend this time reading through the code, see if you can understand it before I get to my explanation of it. This kind of exercise is crucial when it comes time for you to actually jump into a real company's code base. So now is not the time to shrug this kind of exercise off. So pause now and spend some time to gain an understanding of this code. I think it never hurts to just start right at index.js, although we can see here that, well, we're really not doing anything. We're just rendering the app component. But it's good to know that we're not missing out on something important here. Then I'll go to app.js, and we can see this is where the bulk of our logic is happening. We have quite a few imports. These top ones, because the path is starting with a /, indicates that it's one of our own components. Here we've got the sidebar and the editor. If I had to guess, I would probably say that this section on the left is the sidebar and this whole section on the right is the editor. If you looked closely, you might have seen data and gone over to data to see that, well, we have some really basic seed data, or rather it's data that could be used to create some initial notes for us for testing purposes. Although it looks in our case like this is not really being used right now. Back in app.js, we can see we're also importing something called split from React Split. If you really went above and beyond, you might have actually done a Google search for React-Split to see what it's doing. And it turns out it's a third-party library that we installed as one of our dependencies right here. And it allows us to have this split pane that is easily resized by the user. So that's pretty cool. We're also importing NanoID, which you may or may not have seen already. And it looks like we're using it right here when we're creating a new note. Hopefully this also illustrates the importance of naming your functions and variables with a meaningful name. When my function is called createNewNote, it becomes really obvious what this function is supposed to do. So then we come down to our actual app component, and it looks like we're saving all of our notes in state, initializing as an empty array, and then we're creating this state called currentNoteID. And it looks like it's initializing it either as the ID of the very first note, or an empty string. Now you may have seen this first part and been a little bit confused. Honestly, that's okay, but as a side note, this is one way to essentially say I need to make sure that notes at the index of 0, because notes is an array, exists before I try to access the ID property of that note. When we initialize state as an empty array, in other words, when I refresh this app and I have no notes, notes at the index of 0 is undefined, and trying to say undefined.id will actually throw an error in JavaScript. Again, that wasn't totally necessary for you to fully understand, but that is an error you're going to run into quite a bit. In more updated versions of JavaScript, there are different ways around this, but that's outside the scope of this course right now. Next, we've got this createNewNote function, which is relatively self-explanatory. Based on this setNotes call, it looks like it adds the new note to the beginning of the list, and then it looks like it sets the current note ID based on this note's ID. At this point, I might not totally understand what the purpose of setCurrentNoteID is, but that's okay. This update note looks like it is a way for us to save in state any changes to our notes that we create, which allows me to actually type something here and have that be saved, at least locally in state for now. Find current note. Well, this isn't setting state or anything, so that doesn't seem immediately obvious what it's doing. But if we look a little further down, we can see that it might be a helper function that is helping us determine what the current note is. And we're doing it both in the sidebar component and the editor component to pass the current note down as props to that component. Again, if I were looking through this code base for the first time and I saw this split component, I would probably end up going to the React Split documentation to try and better understand how that works. It looks like we are conditionally rendering this split component if the notes array is greater than 0 in length, but otherwise we have this section here, which is what we get when we first refresh the app and we have our title and our button. So that's a good enough start in here. Let's go look at our sidebar. Immediately, I see this props.notes.map, which looks like it's taking the array of notes and mapping it into some note elements, which are then being displayed down here. This will show up better when I actually create a note. And if I create more notes, it looks like we have this class that actually changes the sidebar style when one of these notes is selected. That's this selected note dynamically rendered class name. It also looks like when we click anywhere inside of a div, we can set the current note ID, which I presume is what's helping us change this class, and also should be changing what actual text is being shown here. If I call this note 1, note 2, note 3, and then toggle between them, yep, that seems to be saving, or rather correctly displaying, the text that gets shown up in our editor. Then in our editor itself, this one seems fairly straightforward. It is maintaining its own state, and it says selected tab, although the default here is right, and so I'm guessing that has more to do with this little tab up here, right or preview. And if you did take the time to go search for React MDE, you might have seen that this React MDE component, it takes a prop called selected tab and on tab change, and that is something that's built into React MDE. Now something like this, which is creating this converter object and has something called showdown.converter, I assume unless you have done some kind of markdown to HTML conversion before, this is probably completely foreign to you. Something like this is probably not super imperative for you to fully understand in order to understand the rest of the code base. However, it certainly wouldn't hurt to go to Showdown and look at the documentation to see if you can at least gain a general understanding of what it's trying to do. Okay, now I know that was pretty long-winded, but the truth is I'm really hoping that you spent even more time than that trying to understand everything here. Fortunately, in this environment, you also could have just started clicking in here and making changes to see what kinds of things you could break. Curiosity like that is going to be really helpful for you when you're trying to understand how something works. Now, since this screencast is getting a bit long, I want to, in the next screencast, start talking about the features that we want to add to this note-taking app. Let's take just a minute to look at the features that we will be adding to our Markdown Notes app so that it's at least a marginally usable app. The first thing we're going to do is sync all of the changes that happen to our notes with local storage. We won't be saving anything to a database in this project, but at least so that we have a way to save our notes between refreshes of the app, we're going to be using the browser's local storage to save every little change that happens to those notes. Next, we're going to fix the thing that's just showing note 1, note 2, note 3, because, well, that's not very helpful in terms of trying to find our notes going forward. Essentially create a note summary and use that as the title. In reality, it's just going to take the first line of our note and put that in our summary title right there. Next, we're going to add a feature where every time we modify a note, it bumps it to the top of our list. That way we have our most relevant notes living near the top of our list instead of possibly buried way deep down on the list. And then last, but certainly not least, we're going to add the ability to delete notes. Along the way of adding these features, we are going to learn another thing or two about React, so that's going to be exciting. So assuming you've taken the time to really dive deep into the code and understand how this project is working currently, that means you're ready to jump in and start working on this first feature, which we will be working on in the next screencast. Let's start with the very first feature, and that is to sync your notes with local storage. In case it's been a minute since you've used local storage, or if this is the first time you've ever accessed local storage, I created a little slide here that should help you get started. This link up here will go to the MDN docs for reference, but essentially you'll be using localstorage.getItem and localstorage.setItem to interact with the local storage API. When you're using getItem, you provide a key, and that key is like an object, a way to access the data that you saved in local storage. In our case, I'd probably recommend calling this notes instead of key. And then when it's time to set the item in local storage, you will both access the key where you want to save this and the value that you want to save. Now, it's important to remember that value has to be a string when it's saved in local storage. So if you have something that's a little more complex, like an array or an object, you'll need to use json.stringify to turn that array or object into a stringified version, or rather a JSON version that can be saved in local storage. And when it comes time to pull that out of local storage and use it as regular JavaScript, you'll need to essentially reverse that by using json.parse. So that brings us to the written part of our challenge. Every time the notes array changes in state, you should save the array of notes to local storage. Once again, I put here that you'll need to use json.stringify to turn that array into a string in order to save it to local storage. And as a second part of this, when the app first loads, you should initialize the notes state not as only an empty array, but instead with the notes that are saved in local storage. Since at this point you'll be pulling things out of local storage, you'll want to use json.parse to turn that stringified array back into a real JavaScript array. Now, to avoid a kind of confusing bug, I'm going to add a little extra piece of information here. Your code for part 2, when you initialize the state, will go right here in place of this comment. But what I added was an or empty array. What that really does is if you are trying to get data from local storage and it doesn't exist, it's going to return undefined, but we can't set our notes array as undefined. So if that does return undefined, it will instead use a brand new empty array. So I'll put this back to indicate where you should be adding your code for part 2. The last thing I'll say is that this challenge is a little bit trickier, and it's because I'm being a little bit vague. I'm telling you the feature I want you to add, and I'm giving you a little bit of a hint onto how to actually code it. But the tricky part is that you are going to have to reach back on the knowledge that you've learned throughout this course to figure out exactly how this should work. So the time is yours. Pause the screencast and work on this challenge. The main thing that I left out for challenge part 1 is that in order to interact with the local storage every time the notes array changes, we will want to set up a side effect in React. And of course, that's what we do with react.useEffect. I'll provide a function here for the first parameter, and the second parameter I can add now because I want this effect to run every time the notes array changes. Okay, so every time the notes array changes, I want to use local storage.setItem because I'll be updating the notes key inside of local storage. And I can use json.stringify to stringify the notes so that my array can essentially be turned into a string and successfully saved to local storage. And I believe that's it for part 1 of this challenge. Now that it's saved in local storage, part 2 is for us to actually access that local storage so we can, in a way, preload our app with whatever notes we've previously saved in local storage. So here I can move this onto its own line just to save a little bit of room. And we'll say I should initialize state by accessing local storage, getting the item with the key of notes. And because this will come back as a stringified value, I need to use json.parse on the value that gets pulled in from local storage. And you know what? A small correction to make. If local storage is unable to find anything at that key, it doesn't actually return undefined, it returns null. The only reason that makes a difference is because if you try to json.parse null, it will return null, which is a falsy value, and therefore it will use the empty array. But if instead it tried to json.parse undefined, you actually get a syntax error that would crash your program. So in that case, it's probably good that it returns null instead of undefined. Okay, let's test this out. I'm going to clean up this challenge. I'll hit save. And oh, I was so close. This should be get item, not get. Let's hit save again. Okay, we have no notes. I can create one. Even just creating that note should have updated the notes array, which means that if I hit refresh, awesome, we're starting with the notes that we left off on. If I make a change to the note here and hit refresh, those changes are here. Awesome. If you wanted, you also could open your developer tools, go to the application tab, and see that you have local storage that's being saved here on the Scrimba site. Now, obviously, local storage is not a perfect replica of a real database that will permanently save your data. But you can see in just a few lines of code, we were able to add a feature that made this app much more usable than it was before. So awesome work adding this feature. However, there's one tiny thing that we need to learn about to make this a little more performant than it currently is. So we're going to take a quick aside before adding any more features and learn a new little fact about React State. There's one little thing that I wanted to talk about regarding how we're initializing our state when we're pulling from local storage like this. Now, of course, whatever value we put inside of react.useState here in the beginning is just an initial value. So really, we know that it will only set this value when the app first loads. After it loads, React is going to maintain any changing state internally behind the scenes. However, there is something that we need to see. And I can illustrate that by creating some new state. In this case, it really doesn't matter what it is. We'll just say state and set state is equal to react.useState. The reason it doesn't matter is because I'm actually going to put a console log statement which will run every time this line of code runs. Let's just put state initialization. I'll open up my console, and when I hit refresh, we can see that we get that console log running, state initialization. But now I want you to think about the nature of React and what happens when any other state in the app will change. For example, if I add a new note. Anytime state changes, like adding a new note, the entire app component will get re-rendered. Well, if React is in charge of saving the initial state in the background, then it might seem intuitive that it's not going to run this line again. However, if I maybe add a new note, we can see that it does run this line again. And that's because all that's really happening is React is rerunning this entire function. In the background, it is ignoring the state that is trying to reinitialize here, but if there is code, such as running a console log, or in our example, getting something from local storage, it's going to run that code again, even if it doesn't use the value as its new initial state, because it's maintaining that state elsewhere in the background. Now, for direct commands in JavaScript, this is not a big deal at all. For example, running this console log is so minuscule in the amount of time it takes for the browser to run this line that it's completely negligible. So even when we're making changes here, you can see that it kept running that state initialization console log, but because it takes so little effort for the browser to run that code, it's not a big deal at all. However, something like localstorage.getItem is a bit more of an expensive call, or rather it takes more effort for the browser to dip into local storage and get something every single state change that happens in our app. As such, React has implemented a way for us to really easily make it so that any expensive code that might be running inside of our state initialization can happen only one time. And this is called lazy state initialization. It sounds a lot more complicated than it is, because in the end, all I need to do is instead of providing a value, I can provide a function that returns a value. So here, if I provide a function that returns console log of state initialization, and let me put this down onto its own lines here, I'll hit refresh. We get the very first state initialization, but then any changes I make don't rerun that code. In the end, this might seem a lot more verbose than what we had, but if we make use of arrow functions and implicit returns, I can undo this to the way it was. All I really need to do is put a set of parentheses and an arrow. Even still, this is getting a little bit long, so I'll put this onto its own line so you can see the whole thing. But we get the same effect. I can hit save and start making more changes to state, which don't rerun our state initialization console log. Now, this state was completely contrived. Running console log inside of state is pretty useless, but it does lead us to our next challenge. Your task is to lazily initialize our notes state so that it doesn't reach into local storage on every single re-render of the app component. If you were paying close attention, you'll know that this will only require a few extra characters on your part to type in. Pause now and work on this challenge. All we should need to do is add a function here at the beginning of our call and have it implicitly return the value that we had before. Just adding the parentheses and the arrow should lazily initialize this state so that it will only reach into local storage the first time the app loads. In this case, we may not notice much of a difference, especially since we got rid of our console log that we had before, but we can rest assured that this is going to work the way we want. I can hit save, which refreshes our app, and it is successfully pulling in the notes from local storage. Okay, so that checks off this sync notes with local storage feature that we just added. Next, we're going to think through how we can add some more meaningful summaries here instead of note 1 and note 2. So let's do that in the next challenge. Next, what we'll work on is adding some real note summaries as the title for our notes instead of note 1 and note 2. Right now you can see when we're mapping over the notes, we grab the index and we display note and then the index plus 1. Unfortunately, this doesn't give our users any idea as to the contents of that note. So your challenge is to try and figure out a way to display only the first line of the note's body property. By the way, note.body is the text that is showing up here in the editor. And that first line should be pulled out and used as the summary that shows up here in the sidebar. The CSS should already be set up so that it will truncate that so that it doesn't wrap around really long in case you do have quite a long first line in your note. And I've added a couple hints here to help you along the way in the challenge. First of all, the text of note.body, if you console log it, will not show that every time you hit return in the text editor here, it's actually inserting a new line character. Let me show you what I mean. If we go to app, and we're just going to piggyback on top of this use effect that is running every time the notes changes. If I console log notes at the index of 0.body, and we open the console, you can see the text shows as if it were just a space in between the note summary and the beginning of the note line. However, if we actually JSON.stringify this, we can now see that there are two new line characters that are sort of hidden between that first line note summary and the second line beginning of the note. And since we have a new line character that can help us out, your challenge here essentially becomes one of a JavaScript algorithm challenge. So in reality, it's not even really a React-specific challenge. I've given you a second hint here that you can look at if you feel like you need it. I'm purposefully a little bit vague in the language so that if you need to, you can go out to Google and try to find some resources that will help you solve this challenge. Speaking of which, it's time to start. Pause now and work on this challenge. Hopefully while you were working on this, you came across the string.split method. While I'm testing things out, I can actually make use of what I have here. Let's get rid of our JSON.stringify, but we'll just access the body of the very first note in our array. That's going to be the string that we can run a split method on. And the divider we can use is the new line character, which is \n. Let's just see what this returns. I'll hit save, open my console, and awesome, it looks like we get an array that's split on the new line, or in other words, it uses the new line character to determine when a new item in that array should be created, which means that if we just want the first line of our note, we should just be able to access this array that .split returns by the 0 index. So over in sidebar.js, I have access to each individual note, and instead of this note with the index, we'll just insert some JavaScript with our curly braces, and we'll say note.body, that's our string, .split on the new line character \n. That will return an array, and we'll just say at the index of 0, which should access the very first line of our note. Let's see how we did. We'll hit save, and awesome, look at that. I suppose if you want to get picky with it, you could remove the hashtag, although if somebody decides not to put this hashtag header the way that we have, maybe they wanted to make this bold instead, then we would no longer have a hashtag to parse out, but instead some asterisks. Personally, I don't think it's that big of a deal. We'll probably just leave whatever markdown marks end up in that first line just as they are. Now I can see I'm console logging everything because I set that up here on line 18. I'm going to clean that up. And now if I change my note summary to something else, looks like that summary is updating on every keystroke. Awesome work. Speaking of modifying the notes, that leads us to the next feature that we're going to add, and that is to move any modified notes to the top of our list. If we had, say, 50 notes here and we scrolled down to the bottom and modified one of them, that might be a good indicator that we're interested in updating that note more regularly. Let's say we instead had, I don't know, maybe 50 different notes here, and we decide we want to make a change to this bottom one. We probably want to bump that to the top of the list so that it's more easily accessible going forward. So that's the next feature we're going to add in the next screencast. It seems like a sensible feature to add to our app that if the user ever edits a note, in the sidebar it should pop up to the top of the list. So in an effort to give you real practice on adding a new feature, all I typed out was what the user experience should be, and it's up to you to figure out how to implement it. Whenever the user edits a note, reposition it in the list on the sidebar to the top of the list. I suppose as a quick hint, I'll let you know that you will have to refactor some of the existing working code in order for this to work. Pause now and work on adding this new feature. We have a function that exists that we can tap into whenever the user is editing a note, and that's our function down here, update note. Currently, we're using the map method so that the array of notes stays in place in that array. In other words, if they edit note 1, it will always stay in the third position because that's just how .map works. It returns a new array where every original item is at the same index in the new array as it was in the original array. So if we're wanting to rearrange this array, there may be a way to use .map to do that. However, off the top of my head, I can't think of it, and I'm guessing it would probably be so clever that it might be difficult to understand if we're reading our own code or another developer is reading this code in the future. So sometimes when I'm making modifications like this, what I like to do is just duplicate and comment out the code that was working, and then even make a note for myself, something like, this does not rearrange the notes, or something like that that will help me remember what I'm doing. And then up here, at least temporarily, I might say something like, try to rearrange the most recently modified note to be at the top. Okay, I'm still going to be running set notes, and I will still need access to the old notes array, but instead of immediately returning the array that comes back by calling .map, I think I'm just going to start fresh. So let's see, I think that's here, yep. And to give myself some breathing room, I'll open up this function. And honestly, I think the easiest way to do this might be a pretty imperative way. I'll type this out as pseudocode to start. So I'm going to create a new empty array, loop over the original array, and if the ID matches, in other words, if the ID of the note that we're currently looking at in our loop matches the current note ID that we're saving in state, just like we have here, note ID triple equals current note ID, then that means it's the note that we're currently editing, and that means that I want to put the updated note at the beginning of the new array. If it doesn't match, so else, push the old note to the end of the new array. And after my loop is all said and done, we will return the new array. Hopefully that pseudocode makes sense. It makes sense to me, but that's kind of the point of pseudocode. Write it so that it makes the most sense for you. And I like doing this as a way to lay the problem and the solution out and solve any issues I might see at this point before I dive deep into the syntax of the code that's required to actually solve this challenge. So let's do this. We'll create a new empty array. We'll say new array. We'll loop over the original array. I'm just going to use a good old-fashioned C-style for loop. So we'll say I equals 0. I is less than the old notes.length. And I++, move my pseudocode inside here. So if the ID matches, in other words, if old notes at I.id equals the current note ID that we're looking at in state, then I'm going to use new array.unshift to push a new item to the beginning of the array. And I can just take my old code here because I'm accessing the old note. Now, one issue with copying and pasting is I have this object called old note, which I am not referencing anywhere in my code. So I'll need to change this to old notes at the index of I. Before I get too far down this road, I really don't like indexing into things a whole lot. I think I'd rather say old note equals old notes at the index of I. And that way I can use old note over and over instead of having the weird syntax of the index there. So as we're looping through our old notes, if the ID of the one we're currently looking at matches the one that the user is currently editing, then add this new object to the beginning, which has the updated text and all the old properties, just like we were doing before. But otherwise, we can just push to the end of our new array the old note, because we don't plan on modifying it at all. We can clean up some of these comments. Then lastly, we just need to return new array. As you can see, this is a lot more imperative with our C-style for loop and everything, but let's hit save. We'll go to note 1, make any kind of modification like hitting return. Uh-oh, it looks like we have a bug here. Oh, and you probably saw this while I was updating my old note here, but I left this as old notes instead of old note. Little things like that will get you all the time. Let's try this again. I'll hit save. Note 1, hit return. Awesome. Note 1 just popped to the top of the list. We can test this with some other ones. Maybe I make a change here. And sure enough, it's at the top of the list. And note 1 is still modified. And of course, now it's at the top of the list. Awesome. At this point, I can probably clean up some of my comments if I'm not going to be needing any of that old code or anything like that. Although it might be helpful for a future developer to see that your code is written the way it is because you want to put the most recent change at the top. So maybe I'll just update this to say, put the most recently modified, well, that should say note at the top. Awesome work, and that does it for this challenge. The next and final feature that we are going to add to this app together is the ability to delete notes. So that's what we'll tackle in the next challenge. The very last feature we're going to add to our Notes app is the ability to delete notes. I've made a few changes since you last saw this app, so let's talk through those. First of all, in the sidebar, I added a button that has an icon inside, and this icon has a trash icon that's a pure CSS trash icon. I didn't create this, I copied this from a site that has pure CSS icons, before you think I'm some kind of genius in CSS. And I set that up so that it will only show up when you hover on one of the notes. So as I hover over the sidebar note, the little trash icon shows up. Right now, clicking it doesn't do anything. That's going to be your challenge. However, you can see that clicking the trash icon is also changing the selected note in the sidebar. And that caused me to run into a bug. And so I started some of this code for you. We've got the function delete note that will receive an event and a note ID, and I wrote this line out for you, event.stopPropagation. Without going too in-depth, what it does is it says when this trash icon handles the click event, stop propagating that click event to the parents, like the sidebar div that's holding this entire note. In other words, this trash icon is a child element of the note on the side here. And so when I click the trash, currently it's propagating that click event through to the parent, which is also handling a click event. Now, the fact that it is still propagating that should tell you that my trash icon is not correctly using this delete note click event. So that's going to be part of your challenge. Before I read through it, let's go to the sidebar. You can see I specifically indicated where you need to add your onClick event handler. So let's look at the challenge. It's to complete and to implement the delete note function. Now, I've given you a couple of hints here. The first one is to think about what array method you can use to return a new array that has filtered out one of the items, in our case, because we're just deleting one item, based on some kind of condition. Hopefully the language of that hint can give you a pretty good indication as to what array method you can use. I also want you to look closely at the parameters that we're passing to delete note. Keep in mind that normally on an event listener, we don't get to choose what parameters we're passing. So you'll have to find a little workaround, which we have talked about in the past, in order to pass both the event object and the note's ID. And this is the ID of the note that is going to be deleted. As an aside, the reason that I had to do the stop propagation isn't just because I didn't want to select that note, it's because I was getting an error. I would delete the note and then it would try to select it as the current note after it was deleted, and that was throwing an error because that note no longer existed in my array of notes. Okay, I've talked long enough. Now's your chance to complete this challenge. Pause the screencast and try to implement the delete note function. Before we work on the code here, let's test to make sure that we can successfully add the event listener to the trash icon button. I'm I'm going to just add a console log that says deleted note, and then maybe I'll add the note ID just to make sure that I'm successfully passing down the correct note. And then we need to pass this function down through props to our sidebar component. We'll add a new prop called delete note, which will just be the delete note function. And then in the sidebar, we're already receiving props, so I will add an on-click event handler here. And your first inclination might have been to just pass props.delete note here. However, that's why I provided you the hint about what parameters we're passing to this function. By default, whatever function we pass to an event handler will receive the event as its parameter. And in order to pass something else along with that, I'd either need to do some kind of magic with .bind, which I'm not going to get into, or more simply, I can say this is my function that I want to call, this entire anonymous function, and the first line or only line of that function will call delete note. That way I can take the event that I'm receiving as a part of the onClick callback function and pass it along to my delete note function, but then I can also tell it to pass the note's ID. Remember, we're here inside of .map and we have access to this note variable which has an ID property, and that's what we're passing down to delete note as we're calling it. I'll get rid of this line here. I'll hit save. Let's open up the console and click the delete icon here, and awesome. Okay, and it's good that these IDs are different so that I'm not getting some kind of captured value or anything weird like that. So now let's go to app.js and finish implementing the delete note function. I gave you a pretty good hint in my first hint when I talked about filtering out an item, and that's because we are going to use array.filter, but in our case, we're only going to filter out the one item based on this ID. Since I'm updating my state, I'm going to call setNotes. I do need access to my old array of notes, so I'll use the callback function with old notes as the parameter, and I want to return a new array that results from calling oldnotes.filter. .filter takes a callback function, and whatever we return from this callback function needs to be a Boolean to indicate whether the current item we're iterating over in the original array should be included in the new array or not. So we'll say that for each note we're looking at, I want to make sure I include items whose ID property does not equal the note ID that we're trying to delete. This only has one parameter, so I can remove these extra parentheses. So once again, we're looking at all of our notes. We want to run the filter method. We're going to look at each note in that array. And if the ID does not equal the one we're trying to delete, then this will result in true, which means I do want it included in the new array that I'm returning from .filter, which means essentially if it's not the one that I click delete on, it will leave it alone and continue to exist in the array. However, for the one note that I did click delete on, note.id will equal note ID, and therefore this will be false, and therefore that note that I click delete on will not be included in the array, and thus it'll get removed from my state. I'll hit save. Let's click delete on note 2. And awesome, we have note 1 and note 3 left. I can click delete on note 3 and note 1. We have no more notes in our array. If I hit refresh, we're still at no notes. I can create notes, and everything seems to be persisting exactly as we would expect. Now, I totally understand there were probably two really difficult parts in this challenge. One was understanding how to use .filter. In truth, you don't have to use .filter. You can do something a little more imperative, like what we did up here, where we just created a new array and manually iterated over with an old style for loop. If you did it that way, that's completely okay. Obviously, this .filter gives us a chance to do it in a really succinct way, but that doesn't necessarily mean it's the only or best way. And then the other tricky thing that may have tripped some people up was adding this callback function that calls props.delete note. But as a quick reminder, if you ever really need extra parameters other than just the event in your callback function, then you're probably going to pass a whole callback function here instead of just calling props.delete note, so that you can pass whatever parameters you want to your own function. And that brings us to the end of this Notes app. Hopefully you were able to complete all of these challenges that we worked on together. I know that it's difficult to jump into a new code base and try to add features, but there's almost no better practice for you as you're learning React than to jump into an existing code base and try to figure things out. We've come a super long way since we first started React. So as a final hurrah in this course, the next thing we'll be working on is the final capstone project for this course. And this will be one that we create completely from scratch. Since we're going to be jumping into a new project, I highly recommend you really soak in everything that you are able to learn from this Notes app and even go above and beyond with it. If you don't feel like you've gleaned all the information you could from this app, then stick with it. Try to add new features. Even try something small like changing the design of it to better fit your personal preference. Then once you feel like you've soaked up all the information you can from this app, we're going to jump into the final capstone project for this course. Here's the game we're going to be building as our first major capstone project. If you haven't played Tenzies before, it's a dice game that's usually better suited for younger children, but because of that, the complexity is low enough that it makes for a pretty good project here. The idea is to try and roll 10 dice that are all the same, and in our game, you can click on one of the dice to hold it, and when you click roll, those held dice won't change. We'll click the other twos and we'll just kind of play this game until all of the dice that we roll are the same number. And as soon as we hold the last dice, the game is going to notice that we have all twos. It'll play this fun confetti drop here. It'll change the button from roll to reset game. And of course, when we click reset game, it will start us all over from the beginning. The design for the game can be found here. If you click this screenshot, it'll send you to the Figma file for this game. And I included a little animated GIF just in case you forgot how this game is supposed to work, so you can reference this as well. Feel free to peruse the code that we have here. You can see it's less than 100 lines of code in the main app.js component, which contains most of our logic. So get geared up to create an awesome React project. When you're ready, let's jump right in. All right, we're starting from the very beginning. The only thing I've added is some really basic styling for you, and I've included some Google Fonts for you, but there is nothing in our React code at all. So your challenge is to create a brand new React app. I want you to create a separate app component that will live in a separate file. And then here in index.js, make sure to import that app component and render it. Inside the app component, it should render a main element. And then for now, I just want you to style everything to look like the basic outline for our game. You can click on the slide to go to the Figma file where you can find some of the design elements, well, specifically this background color. So pause the screencast and set up our Tenzies game. Okay, let's import the things we need. We know we need React from React. And because we're going to be using React DOM, we'll have to import React DOM from React-DOM. While I'm importing things, I'll import app from a non-existent app file. We'll get to that in just a second, and we'll use React DOM.render to render an app component. And the place we want to render it is in the element that we get from getElementById root. Let's create our new file for app.js. We'll import React from React and export our component. Like I said, we'll have it return a main element. Maybe I'll just put something here so I can see that things are working. Okay, pretty underwhelming. Now let's get to some style. I can see that from the design, it looks to me like the entire body probably has this background color, and then the main element is this white box here. So in the body, I'll give it a background color, which from the design we can see is this color. And since my main element is essentially going to be the container for everything, I don't think I'm going to bother with adding a class name really. I'm just going to have the main element that I style. And it looks like that background color is not white in the design. It's this very close to white color. Let's add a little bit of padding to the body so that there is that blue outline around our main element. We'll say maybe padding 20 pixels. I'll add a height to my main. We'll say it's maybe about 400 pixels. I I could probably use a percentage or use view height. For now, this will do the trick, and if I need to, I'll come back later and update that. And then maybe instead of a width, I'll add a max width and say something like 800 pixels. Because of the padding we still have that little outline on the sides. The max width makes it so that it doesn't get too wide if we get really wide, but I don't think that's going to be a problem that I'm going to be too worried about right now. Looks like we have a bit of a border radius, so we'll add maybe 5 pixel border radius. And there certainly will be more styles that we decide to add to this later, but for now, I think this is good. I'm going to get rid of my something text here. And awesome, this is a great start. Next, let's see if we can add our little dice components onto the screen. We won't worry about any data or generating the numbers quite yet. We'll just get these components working. So when you're ready, let's move on to that. The next thing we'll do is get some die components rendered to the page. For now, we'll just manually put in 10 instances of our die component, and in the end, it should look like this. Once again, you can click this slide to go to the Figma file so you can get things like the box shadow and the font size for these and everything. The challenge is written out here. Create a die component. This will be in a separate file, and that die component should take a value prop or a prop called value. Then inside of our main here, you'll render 10 instances of the die component just manually and provide a number between 1 and 6 for the value prop on each one of those for now. And then make sure to style the main component and the die component that you create to look like they do in that slide. And just to make your CSS life a little bit easier, I added a couple hints here. I'd recommend making a container that will surround all 10 of these dice instead of just putting them directly as children of the main element. And that way you can make that container a display grid, so you can make it always display in 2 rows of 5 columns. And to get the separation between these elements, you can use the gap property, which will provide this spacing here. And then I would turn the main element, the one that has this white box, into a flex box so you can easily put that container in the center of the screen. Okay, pause now and work on adding some die components that will display our dice to the screen. Let's start by making a new dice component. So I'll make die.js. Sounds a little violent, but that's the correct singular of dice. We'll import React from React and export our component. I know that this is going to take props because we want to display a value prop. And looking at these dice, because I see this white outline around it that is the shape of the die, I'll probably actually make this a nested element, or rather I'll return something like a div, and inside that div is where I'll put the text element itself. Let's call it an h2. And this h2 is going to display props.value. We'll get to styling this in a minute, but let's, in our app.js, import our die component. I'll create that container that I was mentioning. And let's just render 10 instances of our die component. We'll pass in a value, which will just start as 1. And I'll just duplicate this 10 times. Okay, let's see where we are. Okay, that's about where we expect to be. Now let's start adding some styling. First, let me create my grid here. So I'll give this a class name. Let's say this is the dice container. And we'll set that up to be a grid. So display grid, we'll give it a grid template, and I'm going to be specifying a height and width on each of the die components themselves. And so I think what I'll do is just say this is going to be 2 rows that are each auto-determined in their height. And then I'll use the repeat function to say each one of the columns will be 1 fraction unit wide, and we'll have 5 columns. Let me actually refresh one of these components here so I can see this applying live. Okay, that's looking not too bad. Maybe before I provide some styling here, let's go ahead and create the little dice look around it so it has the white box. I'll go to die.js and this div here. Let's give it a class name of maybe die face, since that's the face of each of the die. And I'll save that and go to style.js. Let's style up die face. And we'll give these a height of 50 pixels and a width of 50 pixels. I'm going to paste in a box shadow from the design just so we can see the surrounding area without actually giving it a border. We'll give it a border radius of 10 pixels. And then I want that number to be perfectly centered in the middle. So let's make this die itself display flex, which will allow us to justify the content to the center. And we'll make sure that we align the items to the center as well. Then in our container, let's go ahead and add a gap. So we'll say a 20 pixel gap so that the items can spread out a little bit. Okay, I don't love how they're jammed all the way up to the edges of my main element, so I think I'll add some padding to my main. Let's say maybe about 20 pixels. And then as I mentioned in the hints, I think what I'll do as well is make my main a display flex, which kind of screws it up temporarily, but we'll set the flex direction to column so that the elements are being spread out top to bottom. And that will allow me to justify the content to the center, which allows me to put that directly in the center. Maybe for good measure, I'll say align items center. I don't know that that's going to make a difference. Well, yeah, it actually pushed the items a little more evenly spaced together, so that was good. The last thing I think I'll do is add cursor pointer. Even though this won't necessarily show up in the recording of the scrim, if you refresh this app, you can see that it now changes to that little Mickey Mouse glove hand. The only other thing I can think of is these numbers are looking a little bit smaller than I was hoping. So let me actually render dice with all of the different values on a regular 6-sided dice just so I can see a comparison of the numbers. And then I'll give a class name to the number itself. We'll say class name is maybe die-num, and we'll add some style to that. We'll say .die-num. Let's give it a font size of maybe 2 rems. Is that too big? Let's see. It's pretty large, but it really helps highlight what the number is. And since that's the most important part of the dice, I think that'll probably be good. It also looks like these dice are blending into the background. I'm assuming they probably have a transparent color, so I'm going to give them their own background color of pure white. And awesome, yeah, that really makes them stand out better. Okay, that was a lot of time being spent on CSS, but now what we can do is go in and instead of manually putting in these die components like this, we probably should be generating an array of 10 random numbers and mapping over that array to create these die components. So that's what we'll do in the next section of the project. We'll break up the generation of these dice components into smaller challenges. This is a really good habit to get into when you're problem solving. Instead of being overwhelmed by a larger problem like let's generate 10 random values and create multiple die components based on those values. Instead, break that down and say, let's just make a function that generates an array of 10 random numbers. And then we can tackle the creation of the die components later. So that's exactly what we're going to do. Your challenge is to write a function, you can call it all new dice, that returns for now an array of 10 random numbers between 1 and 6 inclusive. If you can't remember how to generate a random number in JavaScript, a quick Google search will certainly help you out. And then for now, let's just log the array of numbers to the console. Pause the screencast and write our all new dice function. A quick side note on algorithm challenges like this, I really highly recommend that you try to come up with your own solution. I mentioned turning to Google to learn how to generate a random number in JavaScript, but for practice sake, I hope that you didn't just Google how do I create an array of 10 random numbers in JavaScript. Instead, I really want you to put on your thinking cap and try to find solutions on your own before turning to Google. Something like generating a random number is not really a challenge in JavaScript so much as a syntax that you need to use. But the rest of this, creating your function that returns an array of 10 numbers, is really a problem-solving challenge that you should be practicing and not just finding other people's solutions for right away. Okay, I'll get off my high horse there. I'm going to create this function inside of my app component, so we'll say all new dice. And I think I'll break this problem down into smaller parts. So first of all, I need a new array to hold my numbers. I'll probably need to loop 10 times. And as a part of that loop, I'll need to push a random number from 1 to 6 to my array. And then after the end of my loop, I can return that array, which will at that point have 10 new numbers in it. And that should say my numbers. Okay, so we'll say maybe new dice is going to be an empty array. And then I can use just a C-style for loop, should be fine. I equals 0, I is less than 10, I plus plus. We can say new dice dot push. And to generate a new random number, you have probably come across a solution like math.floor, math.random, and then you can say times 6, and then you have to add 1 to the end of it. And honestly, I can't remember what order these are supposed to be in, but instead of adding 1, if you want it to not start at 0, but start at 1, you can actually use math.ceiling, math.random, and I forgot my parentheses there, and the times 6 should be in here, so that was all kinds of problematic. But the point is, this will create a random number from 1 to 6. And then once that number is created, it will push it to the new dice. It will do that 10 times, and at the very end, I can just return my new dice array, get rid of my pseudocoding planning comments, and then let's go ahead and console log what comes back by calling all new dice. Open my console, hit run. Oh, and so close. And you probably saw this when I typed this out. It should be new dice, not new nice. Okay, cool. All of those numbers are between 1 and 6 inclusive, and there are 10 of them, so awesome. That probably does it for this challenge. In the next screencast, we will take this array and we'll turn it into actual dice components. All right, here's the next part of the challenge from before. Let's make use of the all new dice function that we created and create new state to hold this array of numbers. And in fact, when you are initializing state, you can set its initial state to be a call to the all new dice function. And that way, as soon as the component loads, it will generate all new dice for us right at the beginning. Then with your brand new state, you should map over that array and generate the array of die elements that we will use to replace the manual 10 items that we wrote here. Pause now and work on this challenge. Okay, let's create some state here at the top of our component. We'll say, maybe we'll just call this our dice and set dice. And that's react.useState. We're going to initialize the dice state by calling our all new dice function. And then to generate the array of die elements by mapping over our dice, I could either do it directly here inside of my return. I could put my curly braces to put in some JavaScript and say dice.map, whatever. I personally prefer to generate an actual variable that holds that array of die elements, but outside my return, really only because it helps me separate the logic a little bit. Either way is completely fine. So I'll say const dice elements equals dice.map. I'm going to look at each individual die, and I'm going to return a die component with the value prop set to the number of that die. Now, remember, right now we're just iterating over an array of bare numbers. And so here, die really just represents the number itself. And now dice elements will be an array, but instead of an array of numbers, it will be an array of die elements with the value prop set to the same number as the item at the same index in the original dice array. Now I can just render this dice elements array right down here. Before, these were hard-coded and we could see it went 1, 2, 3, 4, 5, 6, and then a bunch of ones. Now when I hit save, we should get a bunch of random numbers that show up here. In fact, it should be random every time I hit save. We'll get a different set of numbers. Now, because we're mapping an array into an array of components, React is warning us that we need to provide a unique key prop to each of these elements. Right now, we actually don't have a great piece of data to use as a unique key prop, but later down the road, when we refactor our dice elements that are in this array from a set of numbers to a set of objects, we'll come up with a solution for providing a key prop here. However, that's not the next step we're going to take. Instead, we're going to create a button that will allow us to re-roll all of our dice so that we can roll our dice without having to refresh our application. So for now, we'll ignore that warning, but we will solve that in a bit. When you're ready, let's move on and create our roll dice button. The next thing we want to add is a roll button that, when it's clicked, will generate all 10 new dice for us. Down the line, we'll be modifying it so that we can hold dice that are exempt from this roll button, but for now, just make it so that it rolls all new dice. You can put your button right here below the dice elements, and well, the rest of it I'll let you figure out. Pause the screencast and work on this challenge. First, I will create a new button, and we'll just have it say roll. Actually, let's just hit save and see where that gets us. And as a reminder, we will be having this warning every time we hit save. We're going to address that really soon. And well, that's pretty abysmal in terms of styling, but it looks like we've got a button there. Maybe let's hook it up first and then we'll style it. Clicking the button should run a function that will generate new dice by using set dice, and we could probably just combine our all new dice to determine what the new dice are. So I'll go ahead and create a function called roll dice, and this will just call set dice. And for now, we don't care what the old dice were. We're just generating all new dice. So we'll just run all new dice to generate the new numbers. And then let's connect the roll dice function up with an on-click handler. Okay, I'll hit save. And when I click roll, awesome, we're getting all new dice. Well, that was simple enough. Now let's add some style to our dice. I'm going to add a class name to the button. Maybe let's just call it roll dice. And then we'll add some styles to the roll dice class. And I'll mostly just be following what we have here in the Figma design. I think I'll set the height to about 50 pixels, the width to about 100 pixels. And I might need to hit save so these can apply live. Yep, there we go. We'll take away the border with border none, but it does have a border radius of about maybe 6 pixels. It's got a background color that we can find in the design. And we just need to spell that right. There we go. The text color is white, so we'll change the color to white. Looks like the font size is a bit larger. Let's call it 1.2 rems. And if I remember right, buttons, I believe, don't take on the correct font family. So let's grab the font family. And oh, it looks like we never set the font family on the body. Let's go ahead and do that now. I'm using this Carla font that I'm bringing in from Google. Okay, we can see that making a difference. We're going to do the same font family on our button. Now this, I don't think, is the greatest practice for accessibility, but just for our visuals right now, I'm going to take away the outline whenever the button is focused. So we'll say outline is none. And this wasn't something in the design, but it's a nice little touch. I'm going to add an active class, which means when you're in the process of clicking the button, it's going to add this inset box shadow, and that will just make it so that it looks like it's being pressed or indented into the screen, which is kind of nice. Now, right now our spacing is a little funny. Let's go ahead and fix that. I think one way I could easily do that is to, instead of doing justify content center, I might try space around, and it puts our numbers a little bit high, especially when eventually we're going to have some text up there. But when we add the text, it might rearrange everything in a pleasing way. So for now, I think I'm okay with the way it is. And yeah, I should be able to click roll and everything is working great. Again, in the recording, you won't see this, but I think I also will add the cursor pointer just to make it very clear that it's a clickable button. And awesome, great job. At this point, it's a great idea for you to do a little self-assessment and see if you were able to accomplish that challenge all by yourself. Everything we did in this challenge should almost be second nature to you now based on the amount of repetition that you've had the opportunity to do. If you did struggle with this challenge, now would probably be another great opportunity to jump back in the curriculum, rewatch some of the lessons that we've done, and more importantly, redo some of the challenges that we've assigned to you. And that way, when you come back to this roll dice button challenge, you can do it comfortably without it being overly difficult. And then, of course, whenever you're ready, the next thing we're going to work on is being able to hold the dice so that when we click roll, it does not change the dice that are held. And that's the challenge we're going to tackle next. The next thing we'll work on is the ability to hold dice in place so that when the roll button is clicked, those dice that we've held don't change. Up until now, we've been saving just bare numbers or integers in an array, But in order for each dice to also contain information about whether or not it's being held, we'll want to change those to an object. So that is your challenge here. Update the array of numbers in state to be an array of objects instead. Those objects should have a value property which contains the number of the dice, or rather the number that is being displayed on each die, and an isHeld property which we will default to false. Don't worry about styling the dice or fixing the roll button quite yet. We're going to do those over the next few challenges. But simply making this change from an array of numbers to an array of objects is going to break other parts of our code. So the next part of your challenge is to bring it back to a working state. Pause the screencast and work on this challenge. I purposefully didn't show you exactly where these changes need to be made so that you would have to do some thinking about it. The place where we are generating the numbers and pushing them to the array is right here. We're creating a new array and just pushing a number that's randomly generated. So let's simply update this line of code. Instead of pushing a number, I'm going to push an object with a value property that contains that number and an isHeld property that contains a Boolean. We'll default every one of them to false. I think I'll put these on their own lines so it's a little bit easier to read. And now every time we call all new dice, we are creating an array of objects. That means down here, when we're mapping over our array of objects and die is no longer a number but is an object, the value needs to be die.value. Let's hit save and see how we did. Okay, well, we still have our warning from React about adding a key property. We're going to work on that in just a second, but let's test to make sure that everything is working. And awesome, looks like we're in a good place. Now, the next thing I'm going to do wades into deeper waters of intermediate or advanced React. So I'm going to explain it in a very surface level way, but just know that for now, it's not terribly important that you truly deeply understand exactly what we're going to do. I want to address this warning that we're getting where each child in a list should have a unique key prop. When you're pulling data from an API and it receives some sort of unique ID generated by the database, that's perfect. That is the ID that you should use for your key prop. In our case, we are not receiving that because, well, we're not calling out to a database at all. We're generating these objects on the fly. Now, the reason this key prop is important in the first place is so that React has a good way to keep these in the correct order in case anything were to be removed or added to this array. In our case, we will always have 10 items in this array, and we don't plan on removing or adding any new dice to our game here. So one solution is to get a third-party package, which I can add as a dependency. I'm going to add one called nanoID. And nanoID is just a really fast way for me to generate a random ID on the fly in my code. What I can do at the top is import nanoID from the package nanoID. And then every time I'm creating this object, I will create a new ID property and just call the nanoID function. Let's take a look at what this generates for us. So I'll console log new dice and open my console. We'll hit save. And you can see the IDs are a little bit crazy. They're not just like 1, 2, 3, 4, and 5, but there's enough bits in that ID that we can essentially be guaranteed they will be unique. And now that I have an ID, I can fix my warning and just say my key on these die is going to be die.id. Let me push some of this onto its own lines. I'll also remove my console log here, and now I should be able to get rid of my warning. Awesome. Okay, so now every one of our dice has the ability to know whether or not it's being held, but we currently have no way to change that. So that's what we'll start addressing in the next part of this project. Very soon we'll be working on making it so that every die knows that when it's clicked, it should toggle its held property from true to false or false to true. But for now, let's add some styling to the die so that if it is held, it can put this green background color. That's going to make our job a lot easier to test when we add the clicking ability for holding or unholding a die. To test that, I'm going to change the dice from is held to false to be is held to true, so that when you work on your challenge, you'll be able to see all the dice turning the light green color, assuming you got everything set up correctly. So your challenge is to add some conditional styling to the die component so that if it is held, or rather if that die's is held property is true, its background color will change to that light green color, which you can reference the hex code for right here. Don't forget that currently the die component has no way of knowing whether or not it's being held. So that's something you'll have to address as you work on this challenge. Once you have all the dice with that green background color, come back to our all new dice function, change this from true back to false, and refreshing the app should then clear out the green colors and it should look the way that it does right now. So pause now and work on this challenge. I think I might work a little backwards in this challenge because first I need to let the die component know whether or not it's being held. Down when I am mapping it, I'm passing a key prop which isn't really usable except for internally by React, and I'm passing this value prop. I'm going to also add an isHeld prop, and that is just going to be the value of die.isHeld. So either true or false, or in our case, all of them will be true because that's how we hard-coded this. That alone shouldn't really break anything in our code, but if I go to the die component, I now have props.isHeld, and I can use that to generate my background color. To do some dynamic styles, I'm going to create a separate styles variable, although this could be something that you handle inline right here by saying style equals and then an object. I think that gets a little bit lengthy, especially if you're adding more than one style. So for now, I'm going to say style equals my styles object that is defined up here separately. And then I'm going to set the background color. This has to be camel cased, remember, because we're accessing the DOM properties of this element. And here I can use the ternary. I'm going to say props.isHeld. If it is held, then I want to use that hex code that we saw before. But otherwise, I want the background color to be white. Let's hit save. And awesome, we get all green dice, just like we expected. For one final test, back in app.js, I'm going to change this back to false, hit save, and that has cleared out. Perfect. I suppose that technically means that my die face no longer really needs a background color that's set in the CSS because that will be handled with an inline style here in React. Maybe I'll just double check that. Refreshing gets me all white dice, and when I change this to true, all green. Perfect. Wow, that's a lot of twos on one roll. That's amazing. It's too bad we're not playing this game yet. Okay, I'll set this back to false because that's where we really want our game to be. And perfect. Now we're ready to start tackling the challenge of having each die be able to hold when it gets clicked. So we'll start working on that next. In the past, we've talked about something called derived state and how, for the most part, it's not something you'll end up using very often. As a reminder, I've brought in this diagram, which we've seen in a past lesson, and adapted it to work for this Tenzies game we're making. In this game, we have our app component, which is holding an array of dice objects, and it's mapping over that array and creating instances of our die component. It's then passing the isHeld property down so the die knows how to display whether it should be green in the background or not. And in this diagram, what we see is each die component containing its own state, which is initialized by its incoming prop of isHeld, and then having the ability to flip that isHeld property from true to false or false to true. Although this might generally accomplish the goal of making each die be able to flip from green to white or white to green, it breaks our game because if each die component has its own state of isHeld, it isn't necessarily communicating that change up to the parent state. And in our game, we need to be looking at every single die so we know how to end the game. If every die is held and every die has the same number, then the game is won. However, if each die is flipping its own state, like I said, there's nothing communicating to the parent array state that it's changing. So a much better way for us to structure this, although it may include a little bit of extra code, is to not put state on any of these components and not have them be able to flip that own state that it initializes from its incoming props, or in other words, using derived state. Instead, we will only keep the state on the app component. We'll create a function that we'll call hold, and that hold function will be passed down to each one of the die components. In our case, we need to know which die clicked hold, And so that hold function will receive an ID as a parameter. If you remember, when we are generating our dice, we create an ID property for each one, which is unique. And as such, it's something we can pass as a parameter to our hold dice function. So that brings us to your challenge. Your challenge is to create a function, we'll call it hold dice, that takes an ID as a parameter. And for now, don't worry about the logic of this function. Just have it console log the ID that's passed in as a parameter. And then I want you to figure out how you can pass that function down to each instance of the die component so that when any one of them is clicked, it will log its own unique ID property. In other words, you need to make sure that when you click the first die, it shows a different console log than when you click the second die. In truth, there's more than one way to make this work. We have looked at multiple different ways to make this work in the past, so you can just choose whichever one makes the most sense to you. So the time is yours. Pause the screencast and work on this challenge. Okay, let's create a new function. We'll just do it right down here. Hold dice. And let's spell function correctly. This will take an ID as a parameter, and it's just going to console log the ID. Easy enough. Now when we are mapping over our dice objects and creating our instances of the die component, I basically have two different ways I could do this. One thing I could do is pass the ID to the die. So this would be die.id. And then also pass hold dice as the function hold dice. And then inside of the die component, I could call hold dice on click and pass the ID that's passed as a prop here. However, to me, this is one additional step without really a lot of noticeable gain. And so I think I'm going to take that out. And then what I can do is just create a new function and say hold dice is going to be this anonymous function. And this anonymous function will call hold dice with die.id as its parameter. Effectively, what this is doing is embedding the ID as the parameter that will be called with the hold dice function whenever each one of these dice is clicked. So I should be able to hit refresh. And of course, at this point, clicking the die isn't going to do anything because I haven't actually accepted that prop on this side. So now I'm receiving a prop called, let's see, it was hold dice here. And I can add an onClick to my div. I'm going to separate these onto their own lines. OnClick equals props.holdDice. So let's hit refresh. I click the first one and I get this ID that starts with HG. This one starts with AYZ, YJB. Awesome. Specifically, I'm checking to make sure that these were all different from each other. If they were all the same, then something would have happened incorrectly as I was passing in the ID. But they're all different, which means each one of these has their own function that can identify which die was clicked, so that in the next part of this challenge, we'll be able to update our state, which is holding all of our dice, to flip the held value, or the is held value, on just the die that was clicked. So that's what we'll do in the next challenge. The next thing we're going to work on is making it so that clicking each die will actually flip its isHeld property, instead of just console logging the ID. Again, the goal is to make it so that I can click the die that I want to hold, have it flip its property, which therefore will change its background color, and then coming up in the future when we click roll, we will create new dice for all of those except for the ones that are held. So your challenge is to update our hold dice function to flip that isHeld property. Again, you'll want to keep your dice array almost exactly the same way as it was, except for the one item that was interacted with based on this ID. As usual, there's more than one way to accomplish this. I'm going to be using dice.map and checking for this ID while I'm looping over the dice inside of my callback function in dice.map. But honestly, if that way is confusing to you, you can just do this whichever way makes the most sense to you. Pause the screencast and work on this challenge. Okay, to update our state, we will need to use our setDice function. So I'll start with a call to setDice. I do need access to all the old dice or the old array before we make this change so that I can determine what the new array should be. And I'm going to use the map method to create a new array or return a new array from this function. And again, almost every die object is going to be exactly the same way as it was, except for one of them, which will just have the isHeld property flipped. I remember when I first learned about this way of updating an array in state, it felt, I don't know, inefficient or something. But in truth, JavaScript does these operations so quickly that it doesn't even blink at something like this. So inside of our map, we're going to look at each die object. We'll have another function, and I think this time I'm just going to open it up so that I have some breathing room on the next line. And here I can use a ternary that says if it is the same die with the ID property that was passed in to the function, then I'll update that object, and if not, I'll just return this die. I can do that by saying return, and then use my ternary to say is die.id the same as the ID passed in? If so, then that's the one we want to change, and I'm going to take all of the properties from the original die, but update isHeld to be the opposite of die.isHeld. I'm going to move this on its own line, and then put my else with this colon, and start the next part on the next line, and I'll just say if it's not the ID that we clicked on or that we interacted with, just keep the same object that we had before. And I think this should do it. Let's hit save. And well, we have a lot of pairs here. Let's just do the twos. Awesome. I should also be able to change my mind, click off the twos and choose the sixes instead. Great. This was one of the major features that we needed to add to this game. The next thing is we need to make sure that when we click the roll button, we don't just lose all of our dice, but instead roll only the dice that we didn't hold. So that's the feature we will work on next. Other than checking if the game has been won, I think this is the last major feature that we need to add to this game. So your challenge is to update the roll dice function instead of just creating all new dice every time we click the roll button, that instead you will look through the existing dice and not re-roll any dice that have been held. As a hint, this is going to look relatively similar to what we did in the hold dice function, at least the way that I'll be solving it. Of course, if you find a different way that you prefer or makes more sense to you, then just go with that way. That'll be great. When you're creating new dice as a part of that roll, remember to use the ID that we are getting from NanoID. That way, any new dice you create will also have an ID and therefore will work when we click them to hold them. Pause the screencast and work on this challenge. Okay, instead of creating all new dice, we do need to now be looking at the old dice. So we'll pass a callback function here to set dice instead of just generating a new value for it. And we'll create a new array by calling oldDice.map. We'll look at each one of the die in the old dice. And similar to before, what we'll do is check the die.isHeld property. And if the die is being held, we want to make sure we just keep it as part of our array. If it's not being held, however, we will return a new die to add to our array. Now, looking a little bit ahead, I can see that here I'm creating a new instance of a die. Down here, I'm essentially going to be doing the same thing. I could just copy and paste this value. However, this raises something called a code smell for me. I can see that we're going to have repetitive code. So this wasn't technically part of the challenge, but I think what I'm going to do is create a separate helper function that's called maybe generate new die. And I'm just going to have it return, let's see, this object right here. And that way, anytime I need a new die, I can just call this function. I think I'll move this up above my all new dice so it's a little easier and more logical to read. Then right here, I'll probably call generate new die. And down here, I'll do the same thing. We'll just say generate new die. Again, that wasn't really part of the challenge, so if you didn't make this helper function, that's completely okay. I just thought I'd show you how I might do it if I were looking ahead and seeing how I was about to have some repetitive code. Let's cross our fingers, refresh. Looks like we have 3 2s here, so I'll probably start there. We'll hit roll, and awesome! Everything rolled except for the 3 2s that I held. I could then hold a couple more 2s. Getting a little bit unlucky with our rolls here. There we go. Get a couple more 2s in here. There's another one. We're almost done. There it is. So that brings us to the next challenge. How do we end this game? Of course, me clicking this doesn't make any difference to the game at all. I could click roll, but nothing's going to re-roll. And we basically haven't told the user anything about whether they've won or not. Speaking of telling the user some things, I think just really quick, I'm going to paste in some elements that will give some additional information to the users. If you remember in this original screenshot, we have the title of Tenzies and a little description. I'm going to add those in now and just paste them in from somewhere else because they're pretty straightforward. As you can see, we just have an H1 that says Tenzies, a paragraph with some instructions, both of which have a class name so that I can add some code in our CSS to style them. I'll hit refresh. I think I'll probably put a little bit of margin below our, dice container. We'll say margin bottom, maybe like 40 pixels. And yeah, that's looking better. Okay, now let's get back to the next challenge where we will start actually informing the user whether they've won or not. We're going to break this up into a few different screencasts and just take this one little bite at a time. Your challenge this time is to add some new state called Tenzies, and you'll default it to false. This new state will represent whether the user has won the game yet or not. Then I want you to add an effect that will run every time the dice array in state changes. For now, you can just console log dice state changed and not worry about doing anything else. If it's been a while since you've gone through the curriculum on useEffect, this would be a great time to go back and review. And once you're ready, pause the screencast and work on this challenge. Okay, so I can create some new state. We'll say Tenzies and set Tenzies is equal to react.useState, and we'll initialize it as false. That way they won't win the game as soon as they load it. And then we're going to add a side effect, and we'll use that with react.useEffect. UseEffect will take a function as the first parameter. And I'll set up the second parameter right now because I only want this effect to run anytime the dice array changes in state. As I mentioned, for now, we'll just console log dice state changed. So let's hit refresh. We get a dice state changed on the very first load, and then it should, every single time I update the dice array, even if it's one small change, like changing one of the dice to being held, then we get our effect running. Also, if I run my roll button, that also gives me a dice state changed. Awesome. Now, it may not have been perfectly apparent why we're using an effect here, and that's mostly because we only did about half of this challenge right now. In the next challenge, what we'll do is we're going to check all of the dice every single time something changes in the dice to look for a winning condition. And if the game has been won, for example, if all the numbers are the same and all the dice are held, then we can set Tenzies to true, and therefore the user will win the game. Keeping two internal pieces of state in sync with each other is a really common reason to use a use effect. We talk about it being a side effect as if it only concerned things outside of this function entirely, but keeping two pieces of internal state in sync is another good reason for it. So this one was short and sweet, but in the next screencast, we will make it so the user can actually win the game. Your challenge this time is inside of our effect. Instead of console logging dice state changed, you'll check the dice array for some winning conditions. First, we're looking to see if all of the dice are currently held and that all the dice have the same value. If both of these conditions are true, then set Tenzies to true and log something like "you won" to the console. Pause now and work on this challenge. Just like before, there are a ton of different ways that you might have solved this one. Hopefully the way that I solved it will ring true to you, but if you found a different way or even a better way, then feel free to share it in Discord. I would love to see people's different solutions for this. In JavaScript, there's a really handy array method called .every. And what .every does is it will look for a specific condition, and if every item in that array returns a true for that condition, then it will, as a .every method, return the value true. This might make more sense if I actually show you. I can check dice.every, and for every die, if every die dot is held, or in other words, if every die has true as an is held property, I don't necessarily need to say triple equals true though, then dice.every will return true. If even one of the dice is not being held, then it will return false. So I can save that Boolean that it returns as a variable. We'll say all dice held, or just say all held, and that's either going to be true or false. So that's a good start to help me have an if statement later that checks if they're all held and if they all have the same value. Now, how can I check to make sure that they all have the same value? Well, if they all have the same value, then I can just arbitrarily pick one of the dice and check all of them to see that they have that same value. For example, I could say maybe the first value is equal to dice at the index of 0 dot value. And now I have a reference point for me to say maybe all same value is dice dot every, and I'll say every die dot value is equal to the first value. And now I have some variables that I can check inside of my if statement whether or not they're all held and if they all have the same value. So we'll check if they're all being held and they all have the same value. Then I need to set tenses to true, and we were going to console log u1. I'll just reuse this console log here. All about recycling. u1. Now you may have asked, why am I going to set tenses to true? There's a few things in the user interface we're going to change if they have won. For example, we won't want the button to say roll anymore. We might want it to say reset game. And we can conditionally render that text based on the tenses value. And as you might remember from the preview, we have a fun little confetti thing that's going to pop out when the game is over. But we'll save that as a special treat at the very end. So let's hit refresh and actually play this game. And oh, well, it looks like we might have a bug here. And after a quick look, it looks like I did not put a callback function inside of my .every. Sorry for anyone who was screaming at me saying I did that wrong. Okay, let's try this again. I'll hit save. Okay, we're back up to working, and oh, look, that's a great start. We got 6 sixes. That's amazing. Okay, we'll hold all those. Awesome, we're making good progress. And we should get our state updating finally whenever I finally roll another 6. As a side note, I feel like this is how every game of tenses for me goes. It's the very last one that I never can get to be the right number. There we go. Okay, let me open the console. You won. Awesome. Keep in mind, this effect was running every single time the dice array changed, which means it ran every single time I clicked on one of the dice and every single time I clicked my roll button. Awesome. We have come a long way. The next thing we're going to do is update a couple user interface things. One is just procedural. That's where we're going to update this roll button. And the next is we're going to have a lot of fun with the confetti package. Both of those should be really simple for you at this point. As a reminder, if you were not able to create some version of this, it didn't have to be these exact methods. But if you struggled with this challenge, it's time to erase it and try it again. Make sure you understand this before we move on. The last two things we're going to do are more just checking boxes, but the ability to complete a challenge like this on your own without any kind of outside help will be a really good self-assessment for you to know whether or not you're ready to move on. So when you are ready, let's tie off the little loose ends of this app and call it done. Okay, it's time to tie off a few loose ends inside of our tenses game. This challenge comes in two parts. First of all, if the tenses in state is true, I want you to change the button text down here to say new game instead of roll. Secondly, and probably the more exciting of the two challenges, is that if tenses in state is true, to use the React confetti package to render a confetti component. I've already included the React confetti package for you, and down here in the slides, I included a link to the documentation for React confetti. I think you'll find it's actually a really easy package to use. In the end, you're just going to need to import confetti from React confetti and then to render a confetti component. Now, in our case, we will only conditionally render that confetti component based on the value of tenses. Also, in the documentation, you'll see that they provide a height and width properties. You just won't really need to worry about those in this case. In the end, once you have the confetti package conditionally rendered upon winning the game, it should look something like this, where the user completes the game and then a bunch of really fun confetti falls down. Okay, these are some fun additions. Pause the screencast and work on these challenges. Okay, let's start with number 1. If tenses is true, change the button text to new game. Well, let's go down here to our button. I think I'm going to put some of this on its own line so we have some extra space while we're looking at it. And instead of hard coding roll in here, I'm going to put some curly braces so I can use a JavaScript expression. And we'll use a ternary because we're choosing between one of two options, either the word roll or the words new game. So I'll say if tenses is true, question mark, then we want it to say new game. And otherwise, we want it to say roll. Okay, let's save that. And we need to spell tenses correctly, of course. Okay, let's see. We've got, well, it's not a great first roll. Let's go with some ones. And I'll play through this quickly so you don't have to watch me do this whole game. Okay, so clicking the last one should change tenses to true and change roll into new game. Let's see if that works. Awesome. Well, I don't love that it's stacking on top of each other. I think I'll just go into the CSS and let's find my button here. And I think it's this one. Let's try making that 150 pixels. Yeah, that looks better. Okay, and then part 2 of the challenge is to render the confetti component if tenses is true. Like I mentioned, I already included the React confetti package, but I do need to import the confetti component from React confetti. And again, we're only conditionally rendering this, and I included a little note here that tells you exactly where to render it. I'll keep my curly braces so I can use some JavaScript, and this time I'm just going to be using the logical AND operator because in this case I either want to render confetti or I don't want it to render at all. So we'll say if tenses is true, then we will render confetti. I'll hit refresh. And at this point, there's something important for you to know about this recording. At the current time, Scrimba's not really able to record anything that happens on a canvas element, which is how this confetti is being played. So I'll play through this game and I'm going to see the confetti work. You'll be able to also refresh this app and see the confetti work, but in the recording, it's not going to show up. So once again, I'll speed through this gameplay so you don't have to watch the whole thing. Okay, so I will click the 2, and sure enough, I can see the confetti dropping. I assume if you completed this challenge correctly, you also were able to see the confetti dropping. Or if you struggled with it, well, first of all, I'd encourage you to go back and try it again. But second of all, you can click to refresh this app now with the code that I've written and play the game and see that the confetti is working. Now, at this point, I'm pretty sure we still have a bug in our game, and that's if I click new game. Yep, look at that. It says that we won again and nothing has really refreshed or anything. So we'll have one more challenge before this project is complete, and we're going to handle that in the next screencast. Here's another example of a challenge that I'm going to be a bit vague about because I want you to think through what steps are going to be necessary to complete the challenge on your own. So the task is to allow the user to play a new game when the button is clicked and they've already won. I won't necessarily play through this entire game again, but you saw that when we clicked new game, it just console logged you won again. And I want you to think through why that is and what you can do to fix it so that it will reset the game. Pause now and work on this challenge. As it stands, clicking the button will run the roll dice function. Currently, there's nothing in the roll dice function that will check if they've already won the game. Now, we could choose to create a completely separate function that will create a new game for us, which would require us to then conditionally render one of two buttons based on whether they have already won, or rather based on whether tenses is true or not. Right now, we're only changing the text of the button when tenses is true, but we're not creating a completely separate button with a different on-click handler. Either way would probably be fine. I think I'm just going to update our roll dice function to handle the instance when the user wins the game. Now, I really want them only to roll the dice if they don't have tenses, if the game is not over. So I'm going to move this code into if tenses, this conditional block here, and then I can add an else that says if tenses is true, in other words, if they've won the game, then first I want to set tenses to false because I don't want the game to still be won. And then I can generate all new dice. So I'll say set dice, and I previously wrote a function called all new dice that I can use to generate all my new dice. Okay, now let's play through the game one more time and see if we can get this to work. We'll start with our 4s this time. Oh, I'm going to switch to 6s because I have more of those. Okay, here we go. Okay, it says new game. We got that console log, which we can probably get rid of. Of course, the confetti package is celebrating our win. And then I click new game and everything restarts. And wow, look at that. 5 4s right off the bat. And at this point, we have reached the end of our journey together building the Tenzies game. However, that doesn't mean it has to be the end. In the next screencast, I'm going to give you some ideas on how you might improve this game quite a bit more if you really want something that you can feel good about putting in your portfolio. We won't walk through how to create those features, but it could be a really excellent way for you to practice your skills instead of just moving forward. I hope you've enjoyed this Tenzies game. It might not be quite as fun to play against the computer, but if you have some dice laying around, I do recommend playing Tenzies. It can be really fun and high energy, especially when you're just trying to get that last dice to read the number that you need and you're racing against other people. So on that note, let's take a look at some ways that you might be able to improve this project. Just because we have completed the Tenzies project together does not mean that the fun has to stop there. Assuming you enjoyed this project even a little bit, I'd highly recommend that you spend some time adding to it. The process of adding new features to the program that we made together is going to expand your mind and really help you internalize the things that we have learned together thus far. I came up with a couple ideas. You are welcome to use them or to do something completely different. Some ideas for extra credit on this project include adding real dots on the dice. Right now we're just using numbers for simplicity in the CSS, but if you really want to challenge yourself with some CSS, figure out how to put real dots on the dice. More on the JavaScript side, you could decide to track the number of rolls that it took to win the game. Along those lines, you could track how long it took to win the game. And then you could save your best time or maybe even the lowest number of rolls to local storage so you can try to beat your record in the future. Obviously, this is not all-inclusive. Be creative, add whatever you want to this project. In the end, being able to show an employer that you not only took a project that you built together in a tutorial, but also added a bunch of new features on top of it, that's going to be much more impressive on a resume and a portfolio than a project that you just sort of followed along with. Great job on the Tenzies game. You should really be proud of yourself. And assuming you were able to follow along with everything and that you would even feel comfortable if, we needed to delete everything and start from scratch, that's an excellent sign that you have really learned what you need to learn from this React course. If you look back, it's pretty insane how much ground we have covered so far. So if you think about it, this is the ultimate solo project for this course. It's going to collect all of the topics that we have learned throughout this course and put it together into a single project so you can really test yourself to see if you have been internalizing all of this new React knowledge that you've been learning. And this project is a really fun one. You're going to be creating a trivia app called Quizzical. It'll have an opening screen here where you can click to start the quiz. It will then pull some trivia questions from a database and display those as a short quiz. Once the user has made all of their selections, they'll click Check Answers, and the app will score the quiz and allow them to play again if they want. Clicking on any of these screenshots will send you to the Figma design file. You can see the 3 different screens here. Just to be clear, this first screen will actually be almost like a separate screen. It's sort of an overlay. When someone clicks Start Quiz, you'll probably want to conditionally render this next section. But this third screen is not really a separate screen. It's just changing the first screen so that it gives feedback to the user on the quiz answers. As always, make sure that you go in and duplicate this to your draft so you can avoid seeing everyone's cursors or selections. And so if you want, you can make any edits to the design. And just like before, you can click the 3 dots down in the menu to fork this screencast to its own scrim for you to do all of your coding in. So let's take a look at the requirements for this project. Like I mentioned, there will be 2 screens, the first one that asks them to start the game, and the second one which has all of the questions in it. Your app should pull 5 questions from the Open Trivia Database API, which if you click the green text here, it will send you to that API. After the Check Answers button is clicked, it should tally the number of correct answers and display it at the bottom. And as always with these projects, you should make sure that they are styled and polished. Clicking the link here on this slide will send you to the Open Trivia Database, which is a really fun API to use. You can click in the upper right where it says API, which will lead you to this page. And it has a fun little generate API URL button that you can click after putting in some specifics about the API. If you want, you can limit it to certain categories, difficulties, and so forth. And it'll just give you a URL that when you call it from your code will give you those trivia questions. As always, I highly encourage you to share your work. Click the Discord icon to go to the I Built This channel in Discord, or you can click the Twitter icon if you're sharing this in public. This project is probably a touch more difficult than what we have worked on together. So don't hesitate to tap into the Scrimba community, ask for help, and of course, when you're finished, be proud of the work that you've done and share it. So, best of luck working on this project, and I really look forward to seeing what you end up building. Before we wrap everything up, I wanted to let you know that I've made a sort of pseudo extension to this course that gives you a crash course on using class components in React. As React evolves, people are trending away from using classes in React, but there's still plenty of reasons to learn how to write React using the ES6 class syntax. In this 1-hour mini course, I talk about why they're important to learn and the ways in which they're different from writing React with function components and hooks. If you are hoping to get a job as a React developer, you will definitely want to take this course to brush up on class components, since you're very likely to come across existing code that is still using them. If you're watching this video now as a part of the Scrimba front-end developer career path and you already have a Scrimba Pro membership, then when you move on to the Advanced React course, this crash course will be the first thing that you go over. So you won't have to go out of your way to see this course, but for anybody else who's watching this course as a standalone free React course, you can click the screenshot that you see here, which will take you to the playlist for that course, and it's completely free to take. You did it. You really did it. It's been a long journey, but you have finally arrived at the end of this course. You should seriously be so proud of yourself, because assuming you've actually followed along the whole way and done all the challenges, you are well on your way to becoming a serious React developer. I've said it before, but my learning philosophy is that the easiest way to get good at anything is to do it the hard way. As such, I've made it a point to include a lot of projects and hands-on work in this course. Let's take a quick look back at how those projects have progressed in each section. We started off by just working with some static pages in React. That allowed us to discover why we care about React, a bit about the JSX syntax and how to make our own custom components, how to apply our own styling so we can really polish our projects, and all of it collected together gave us the ability to build static pages. We used that knowledge to build our kind of silly little static page about fun facts about React, and for your solo project, you built a digital business card. In section 2, we moved on to learning how we can make data-driven pages in React. We discovered how to make our custom components more reusable by accepting props, and how we can make the data work for us by mapping over the data and using that to create multiple instances of our custom components using props to pass in specific data to each one. Then in section 3, we really turned it up to 11 because that's where we started making fully interactive web applications. We dove deep into understanding how to listen for events, how to save state and use state in our components, how to conditionally render certain things on the page, how to accept user input through forms, and how to handle all side effects that might happen using the useEffect hook. Then in section 4, we went all in on practice. We took some existing code with this Markdown Notes app and added a bunch of new features to it and fixed a few bugs. Then we built a dice game completely from scratch. And most impressively, in your solo project, you built a quiz app called Quizzical that accessed trivia questions from an API and scored people based on their answers. I purposefully put these projects in here to help drive forward the curriculum in this course, and each one of the solo projects you did gave you a chance to really test out your skills unassisted to make sure that you really internalize the topics that we learned about. This is truly a huge accomplishment, and you should be super proud of how far you've come. In fact, I think right now you should head over to the Today I Did channel on the Scrimba community Discord server and brag about finishing this React course as soon as you can. In fact, I made it so easy you can click this screenshot to head straight there. So what now? Well, there is a ton more to learn about React, But before I jump into the list on how you can dive even deeper into the waters of React, I'd recommend continuing to just practice everything that you have learned. This might be a great time to just use your imagination and pick a project that's similar in scope to the ones that we worked on in this course, and then just build it on your own. For example, if you don't already have your own portfolio site, you might even consider building one in React. That being said, the React ecosystem is quite large, and fortunately, the community is also quite large. So the first thing I can recommend is I have my own advanced React course on Scrimba. If you're taking this React course as a part of the Scrimba front-end developer career path, well, this advanced course is what you have coming up in the next module. One of the first things I recommend learning about is React Router. This allows you to make what's called a single-page application, which is in a way the opposite of what it sounds like. It means that you can add multiple routes to your website so that it becomes a little more like a regular website. Everything we've done so far has just lived in essentially one little page. React Router allows you to make a multi-page website. You can also learn something called CSS in JS. My personal favorite is a library called Styled Components, but there's a bunch of these out there. Essentially, they allow you to put your CSS directly inside your JavaScript so that you can co-locate the styles with your actual code. If you want to branch out a bit more, you can start looking at Next.js or Gatsby. These are both some really evolved and powerful frameworks that are built on top of React to help you build some really robust static websites or even full dynamic web applications. If you wanted to get deep in the nitty-gritty, you could also start learning about performance and optimization if your code base gets more and more complex, or you're working in an existing code base that really needs to squeeze every ounce of optimization out of it, then jumping into this realm might help you as a developer. And in this course, we only touched on 2 of the existing hooks, use state and use effect, but there are a bunch more that you can learn about as well. I'm so grateful that I've had the opportunity to prepare and to teach this React course. My name is Bob Zarol. I've been your instructor through this course. My username is Bob Zarol pretty much everywhere online, but these days I'm mostly just active on Twitter, so you're welcome to follow me there if you like. You can click the Twitter icon to go to my profile page. Once again, congratulations on completing this course. I'm excited to hear about all the ways in which you're able to apply everything that you've learned. I'm truly excited to hear from you. I love getting constructive feedback on the course. If you have any suggestions for me, I welcome them with open arms. And I'm excited to hear from you about all the ways in which you're able to apply everything that you've learned here.